You should be hearing us now, just like everyone else in the room here, but they don't actually pay attention. We still have a few minutes to go. But you can hear us well, right? I can I can actually hear myself because I have the live stream open, so I'm hearing my own echo with a slight delay. All right. So, muting the conference bridge. Right. Gotcha. Just in case anybody's watching, yeah, we're still working on the setup. And as you can hear and see, it's looking good. This is yellow, it's muted, now it's unmuted.
Check, check, check.
I will hear it with a small delay. Of about 20 seconds.
It's different, but it's sort of, I'm always
So, Skip, we just it's still unmuted. Let's mute it again.
Where's the?
No, it's good. It's good.
Yeah.
I mean, you get your own echo here.
Yeah. Okay. Yeah. Uh-huh.
So, Skip, we do have good audio here. So I'm also playing back the live stream to check on things. Yeah, yeah, yeah. And then you have Okay, so here's what I'm going to do. Since everything seems to be working fine now, we got all the access. We can drop out of this. I will do local monitoring to make sure that our audio is always working and the stream.
Oh, wait, wrong machine.
I can't just switch screens all the time.
Perfect. All right. Cool. I can hear myself reverberating, so this is probably working. I'm going to apologize in advance because this talk was kind of slapped together at the last minute, not rehearsed and not. So you get what you get. I'm going to be talking about Git on Plan 9, obviously, as you can see from the slides, and kind of splitting into a few things. There'll be a bit of a refresher on Git, what it is and how it works. And then I'll talk a little bit about how it's implemented and how it fits better into Plan 9, the way I did it, rather than the way that Torvalds did it. It turns out that Torvalds Git's priorities was not fitting into Plan 9, which I'm very confused by, but to each of their own. Okay, so most people here, I'm sure, are aware of Git and have used it, but it's always good to refresh. It's always good to make sure everyone's on the same page. And sometimes the clear ideas that are in Git's internals are obscured a little bit by its UI. So cleaning up some misconceptions and some ideas about what Git actually is probably in order. So first off, the very basics. What is Git? It's distributed version control. So what does that mean? Version control, obviously, it tracks your code, versions it, allows you to go back in history, allows you to collaborate. Snapshot based, so I'll talk a little bit about why it's snapshot based rather than diff based, and it's offline first, which again, that's one of the things that makes Git interesting compared to the traditional old style stuff or the Plan 9 alternatives that we could use. So, Subversion, CVS, and so on require a central server. So does Venti, so does Fossil. But Git basically, you don't need to be on the same network or on the same computer as the people that you're working with, and you can kind of share the changes around, which is kind of useful for the new distributed development world that we live in. Okay, so version control. I'll just kind of refresh. Basically, you track changes to the code. You sync them, you manage branching and merging. Snapshot based. So Git is basically built around the idea of taking snapshots of the code rather than trying to track changes over time. So every commit is basically an entire snapshot in time of your tree. It's built on it's a Merkle tree, and then the diffs are actually generated from the snapshot. When you do git diff, or try to diff between changes, it just walks down the tree and does the diff on demand rather than storing the diff. And basically commit is, it creates a new snapshot. Merging takes snapshots, applies a whole bunch of transformations and creates a new snapshot. You can think of the snapshots as almost like just taking a snapshot of the current, well, instead of the data, it would be a hash, but the RC to actually generate a hash was a pain in the ass, so I just said, imagine you could just take a snapshot of, you just make a directory and copy the contents of the repository to the snapshot. And you kind of have this in history. You get something like this in Venti fossil systems where you get your dumps nightly, and you can take the dumps manually if you want. But it's kind of building this kind of thing. Local first, so Git is, as I said, a distributed system. It's local because it's distributed. You have to deal with networks not being there, so everything is local first. All changes are made to a local repository, and all repositories are equal peers. So GitHub is not necessary for a development workflow. For example, you can just, if I'm on the same network as another machine, or I can reach them, and I have the auth credentials to, for example, SSH into it, or someone set up a server either way on the machine. I can pull directly from your machine or your machine, and there is no central server needed. That also means that syncing is explicit. You push to a repo, you pull from your repo. So basically, it's peer-to-peer. Just in case I give it another talk, I'll just update the slide. Okay, so what is a Git repo? How is it structured? And I'll kind of give a quick overview of the internals of Git now. Basically, the Git repo is a Merkle tree of snapshots. So you get three different kind of objects in the repository. Well, actually four, but I ignore one in Git 9. There's blobs, which is, yeah, there's blobs, there's trees, and there's commits. Blobs and trees commit, so my. Blobs, trees commit, so my. And then there's some metadata, so you can actually find your find the right tree, and pull the data around from there. So blobs are typically file contents and just contents. There's no metadata attached. There's no file info attached. It's just you take the contents of the blob, of the file, or whatever you're tossing into it, and you put a header on it, compress it, and take the hash of it. So if you have a Git repository, so um, now the question is, do I have, no. I should have prepared a repository here. Um, okay. So you can see that there are objects in the Git repository. So .git/object/hash. These objects are generated by basically slapping a header onto it with the compressed contents of the file, and that is basically what you get to in the object store. Then there's trees, which is basically the contents of a directory. So you get the file name, the permissions, and the hash of the blob that refers to a file. This is where, when you go into a Git repository and you try to do, you're listing the contents of the repository, this is where you figure out what the file name is. And you basically get that by taking a header with the type, compressing that with, and basically compressing the generated tree of the directory listing. So there you have the blob. There you have the object in Git. And then the last thing is the commits. Commits point to the root of a tree, and they contain all the metadata about the snapshot. So they point to the root of the tree, they have the commit message, the author, and they chain backwards to the previous commit so you can generate the history. So you get a linked list of history. There can be multiple previous commits. So for example, if you have a merge commit, it's just a commit, just a snapshot, but you point at two parent tree or parent commits instead of one, or three parent commits, or 75 parent commits. It doesn't actually care. And file metadata does not live there. So yeah, and you get this by basically just generating the commit from the author, date, parent commits in the tree. There's actually one last thing that's kind of nice about Git. It actually separates the author and the committer. So, for example, and you'll see this a lot in the 9.0 repo, someone will mail a patch as a contributor, and we'll grab the patch from the mailing list and say me or Moody or Synap will commit it. So the author information is preserved, but we also know who actually did the commit. It's a nice tool for actually sharing and collaborating. Okay, so, and then there's the last thing, which I ignore in Git 9, but tags. Tags are basically a label for a commit. They're very similar to commits, but they're pointed at a commit, not a tree. As you can see, I'm very good at proofreading and checking my slides. So anyway, they're pointed at a commit, not a tree. and they don't move. So in Git9, I mostly ignore them. There's a little bit where if I get tags when I'm cloning a repo, I'll create basically a branch that points at the commit and unwrap it. So you get, so you lose the tag, the metadata in the tag if you get that, but everything still works well enough. You can still check out a tag, you can still branch it. It's just, I didn't feel the need for tags and I was lazy. Nobody has complained yet, so I think I made the right call. Um, yes.
Does that interact with the go-tos, go repositories, the spot releases, so versions?
So when you,
Those seem to be key tags.
yeah, I don't think that it matters the way we're using it because tags are kind of half transparent. If you basically treat them like a branch, and you, so I'm not entirely sure. There are some ways that Go could tell the difference and it could break things, but I haven't.
Well, I just meant if you publish something with whatever you do with tags, does it realise that that is not the current release? The current version?
That's a good question. I'm not sure. We can experiment after.
Yeah.
I think, and adding tag support wouldn't be hard.
Well, it might just need enough to get that going. So.
Yeah, it's really not hard to add tags. It's just that literally nobody has asked for it, so I haven't implemented it. I think it would probably be an hour of work to do. An hour of work and about 150 lines of code, mostly around formatting the tag and. Okay, and then there's one thing I haven't talked about, which is pack files. So if you saw me trying to figure out what I was doing and went, oh, I don't actually have the, I should have set up a repo. Where was this? Yeah, so when I listed the objects and there was only a directory called pack. What was happening there is Git also, because having all of these little files scattered all over the disk is slightly inefficient, Git also has something called pack files where they basically take all of the blob or all the objects in the repo and convert them into a single file. So they basically, there's a little bit of an algorithm, but basically what you do is you take all the objects, cap them into one file, sort them by some certain criteria, and deduplicate the chunks. Because most of the time you're editing files, you're committing something that's almost the same but not exactly. So why not share the shared parts and only keep the deltas? So while Git doesn't do diff-based, while its model isn't diff-based, the storage is deltafied. And in Git9, what I do is I use content-based dedupe. Torvalds Git actually uses xdiff. So different algorithms. Mine's faster. Though I don't parallelize, so Torvalds Git actually deltafies faster in practice. But we've got better algorithms, damn it. And the other thing that with this is that because you've put everything in a file, when you want to do a git pull or a git push, you only send a pack file. So you pack it up into one thing, and then you do a single transfer, and you don't have to worry about unpacking and tarring up a directory of objects. So basically, a pack file doesn't actually change these are three types of thing that you have in a Git repo conceptually, but it's just an efficient way of encoding that. Okay, so that's a Git repo. And then there's the last thing, which is the metadata. And the metadata is roughly what you get for finding the stuff in the repo. Because otherwise you just have hashes. Everything is a hash up to now. Everything is, I don't want to say, oh yeah, do you, what changes do you have on branch successor of 3BEA363? Yeah. So you want to give things names. So there are a few things that you want to give names to. There's .githhead, which is the current branch. It's a file that just contains the name of the branch, ref heads master. Or you could change it to ref heads, I don't know, front. If you created the Git repo on 9 front, that's our default branch name. Then you have the actual contents of the branch. So and that's the commit hash of the commit. So you can actually go into the repo, change branches by doing, I don't know, echo. Uh, oops. I don't know. Let's go for that. Oops. Wow, I cannot type. What did I do here? You get the idea. I also don't want to mess with my repo. So, but you can just the branches are literally just files that point to a commit. And then within when you commit to the repo, it creates a new commit object and updates the branch file to point at it. A tag is, there are two types of tags. There's the tags with metadata and the thin tags. The thin tags are basically .getrefs tags, whatever, or they're an object in the branch. And then the last thing is there's the .gitconfig, which just configures things like where you pull from. Okay, so that's really all the metadata that you need. There's some other stuff that Torvalds Git puts in there. For example, because Microsoft decided they were going to use Git for their Windows repo, and Windows is a little bit, they've got a few years of code that's accumulated, and then so it turns out that there's some performance hacks you need to do to yeah, the rest of the world doesn't. That's the very short summary. So the reason that I did Git 9 wasn't because I wanted to host 9 front on Git. It's because I had repos that I wanted to work on that were going to run on Unix, but also on Plan 9, and I got tired of trying to manually sync the code, trying to keep an HG mirror and a Git mirror, trying to convince people to use HG, trying to, at some point I went, fuck it. This isn't worth the time. I'm just gonna get one. We need Git. So I basically went, okay, fine. How hard could it be? It's actually, it took a while to get it to usable, but not that much. It, so the way I tend to work, people that know me will notice that I kind of take a stab at a project, back off, give up on it for a little while, and then take another stab and go, wait, why did I find it that hard? So what happened with Git was from the time that I started thinking about writing it and decided, I'd like to build it, to the time it was usable, took about usable enough to self-host was about a year and a bit. The amount of time it took from the second attempt and the first line of code that was written in the current version to usable enough to self-host was about a month and a half. So it turns out it's not that hard to get something that works. And then it took another year to polish and find the bugs and get things to the point where I was confident enough to actually use this to host the 9 front repo. But it actually turns out that getting the basics wasn't that crazy. So and Merlin was the project that that really got me going. Like, fuck, I want to port it to Plan 9. I don't want to grab it back and to copy this stuff back and forth. So yeah, I basically just implemented Git and made my workflow painless. Another good example, though this came way later, is NetSurf. So NetSurf is, for the people that aren't aware, it's a web browser. It's somewhat more capable than Mothra, but significantly less capable than, say, Chrome. It's a friendly fork. Upstream doesn't want muck files. They don't have Plan9 to test on. And really, I don't think anyone here or in the Plan9 community really felt the need to push it hard. The code for portability is well separated. It's cleanly clean. There's a clean abstraction layer. So keeping things, and NetSurf doesn't change that quickly. So keeping a friendly fork where we maintain the Plan9 parts and they maintain the rest of the browser turns out to be relatively. It's a good model. So what we do is we basically, when there are changes that make sense to go upstream, we collaborate. When upstream makes changes, we pull them in and do a merge, and then we add our own stuff on top of it. And the way that Git works, it makes it really easy to kind of, yeah, we're going our own direction, they're going theirs, and we keep in sync. So I think this is a good model for porting code in general, where we basically end up with, hey, look, Plan9 is a weird system. We've made changes to make things fit. Your code, we don't want to burden you with that. We want things to be easy for you, and so we'll maintain the Plan9 part. You maintain the rest of it. And having Git work this way is actually, having Git makes this collaboration much easier than, say, the BSD ports style system where you've got a repo of code to clone something and then apply a bunch of patches. And then you have to do a bunch of work to manually update those patches periodically. I think this is I think the BSD port system has its place, and it makes a lot of sense historically before Git 1. And not everyone was, people used to distribute code in tarballs. They still do, but now it's much lower effort to just clone a Git repo and apply a bunch of patches. So collaboration is nice. And then finally, why are we self-hosting on Git? Because, honestly, just because, this slide is actually slightly misplaced. I'll get back to this. And then finally, Venti. Venti has the right idea. Oh, sorry. This slide is slightly misplaced because I wanted to talk about why are we using Git. So we use Git in 9 front. Again, when I talked about external reasons to use Git, so Git 1 gets used everywhere outside of Plan9. But we're Plan9, we do things our own way. Why are we using Git for Plan9? Well, and there are several options out there. For example, the labs used Venti and Patch. 9front was on Mercurial for a while. Why Git? Why Git? Well, so Venti, honestly, for a project where we're working distributed, everyone's doing their own thing and eventually kind of shipping things back. Or maybe not. Gnome's got his own fucking ants port. And then I've got my own patches to my system. I'm pretty sure a whole bunch of other people have got like the Rio theming patches. So Venti really doesn't have the tools for us diverging and keeping our stuff in sync. It doesn't have the ability to kind of ship changes between people easily, or ship parts of the tree as changes. So you end up needing to kind of build a bunch of tooling around it. We could build it, and that's not impossible, but then what? Set patch, set apply. How about offline work? How about cherry picking? How about I run my own system, and how do I sync it with yours? Well, so Mercurial, again, it's okay. It's dead. The big problem with Mercurial is, well, it's dead. There are places that use it. Facebook has some internal tooling around it, but I think they're trying to move to sapling. The other big problem with it, it's full of snakes. And this isn't in theory, and by that I mean it's written in Python. And that means we need to port Python. We had a port of Python. We were using it. It was Python 2.5. It was a Python 2.5 with a ton of patches to integrate with, say, Factotum and the 9front and libsec and a bunch of the other Plan9 bits that you just expect if you're running on the system, and keeping that up to date with upstream meant a ton of porting work, and so nobody ever did it. So the release that moved to 9front had a nice crashed plane with a little Python logo, snakes on the plane. The snakes are gone. And that release deleted upwards of 1 million lines of code when we got rid of Python. So there's and added about slightly under 10,000 for Git. So, yeah, exactly. I've run ahead of myself and talked about this slide already. So, again, so why Git? Because it's useful elsewhere. It's not just useful on Plan9. It's small and maintainable. It's distributed offline, and you can self-host it. So, sorry, it is self-hosted. We can self-host Plan9 on it. So, for example, git.9front.org. Git.9front.org runs on Plan9. It's running on it's using gitserv, it's using listen, it's using all of the tools that we actually want maintained. And if you're not using the tools, why are you maintaining them? What's the point? If you're not using them to build things, you're not going to run into the bugs. Things are going to bit rot. Things are not going to keep working. So it's important to self-host. It's important to be, if you're going to maintain the system, it's important to use it. This is just my view, but yeah. GitHub.us, it's another example, self-hosted Git repo. And it's also kind of a community hub. So if you want to grab Plan9 software, you know where to get it. Not everyone uses it, but a bunch of people do. It means that to be able to get onto it and to push to it, you need to be using Plan9, or at least you need to have set up a whole bunch of Plan9-ish infrastructure to be able to auth using DP9IK and to push to it. So being able to, so basically having this kind of tongue-in-cheek, slightly, unprofessional but fun little. Okay, fine. Oops. Alternative name, by the way. Slightly tongue-in-cheek, tongue-in-cheek, fun thing. People kind of go, huh, that makes me laugh. You know what? I'll join on. It's not for everyone. Doesn't have to be. I'd be happy to see someone else host something else. But having things like this, actually, I think that there's also tcp80.org, which is, if you want to be able to link to it professionally. And you can also use hjgit.org, I think, to get to 9pen, to this hosting. So there are different names for it. Some of them you might or might not want to put on a resume. GitHub's on my resume. Nobody's batted an eye at it, but there are other, if you're a little bit less daring, there are other ways to put it up. Okay, so, but having this kind of, hey, let's have hosting that you actually need Plan9 to use, helps grow the community, helps get people kind of interested, and helps people get kind of like, hey, I want to try this out. This Plan9 thing is weird. You know what? I should give it a try. So, for example, we have, who was it? One of the core boot related forks. I don't remember which one. I'll remember soon, but they basically went, hey, I don't really use Plan9, but I'd like an account. I'll set up Plan9 to use it. I don't know if they actually did. I don't think they ever went through with it, but they were interested enough to ask for it and tell me that they were going to set up a Plan9 system. So, yeah.
We actually used to load Plan9 right out of Corbett, so maybe
Maybe. But no, I think they just said, hey, we want to have things on a few different Git forges, and this one seems fun. Okay, so Git, how is it structured? So this is the part of the talk where I actually talk about Git on Plan 9, as opposed to just Git and why Git around Plan 9. How much time do I have, by the way? Whatever, we'll find out. Okay, so the structure of Git on Plan 9 is basically, it's actually kind of similar from the Torvalds Git. It's got a core of C programs, which give you access to the structure of the repo and provide ways to manipulate it, and a whole bunch of shell script wrappers. Again, not that different from Torvalds Git, but we have GitFS, which means we can do it better. Oops. This is where I apparently forgot to save the slides. Shit. Okay. I promised people this would be a bit of a disaster, so yeah. Okay. So there's so the core of it's GitFS, but okay. I'll start with the more peripheral bits because we can kind of work through that. So one of the core parts of Git is git save. So what git save does is it basically creates a snapshot of the repo with a commit message and the author and the all the other metadata you need in a commit. So, for example, you give it the name, email address, message, date, and a list of files. And this creates a new repo and a new commit in the repo. So git save is fine, but you wouldn't use it by hand. It's actually wrapped up by git commit. And git commit is a fairly large script that does all of this stuff to figure out, first off, who is the author, who is the committer, because you don't want to type that in every time you're creating a new commit. It finds the current branch because you don't want to commit every branch. You don't want to tell it which branch you're committing to. That's just a pain in the ass. It figures out which commit you're on and what the parents are. So if you're creating a merge commit, git merge will save a record of what the parents are, and then you commit to save that. It'll allow you to edit the commit message, create the commit, and then update the branch to point at the newly saved commit. Because git save just creates the commit. It doesn't actually update a damn thing. So you end up with an orphan commit. So git save is a tool that you use to implement git commit, and that's really the reason it's there. The other parts of it are easier in shell, so you have a wrapper script. Nothing mind-blowing there. You have a core tool and a wrapper. Similar with git send. Git send pushes the data to the repo. It doesn't know which one, but you've got and it doesn't deal with it. It just does exactly what you tell it to do. And then get is kind of the opposite side. So it pulls the data. It's similar to git fetch, but not the same, and it's different enough that there was some confusion. At one point in history, it was called git fetch, and then I went, okay, people are trying to run git fetch and expect it to do what Torvalds Git does, so now it's called git get. Okay, git get just pulls the data from the repo, and then you have git pull that does all the wrapping. It figures out what branches you actually want to pull, pulls them down, And then the interesting one, GitFS. So GitFS lets you explore the repo as a file system. So you have your head, and that head, for example, was written by Synap, of course, which, oh, yes, there are a few recent commits that fixed some interesting bugs in the kernel, obviously. And then you can, oops. Yeah. Remember where you are. So you can basically walk through the files from the gitfs. And you can also, is that it? No. What was in there? Yeah. So that's a commit hash. And really the head is just a, I keep on doing that. Is just an alias for the current commit hash. So you can do everything by hash within the file system. Having this, even though it's read-only, it is really useful for being able to write scripts. So all of the tools like, git commit, git revert, git merge, etc., are all, super simple little wrappers. So, for example, git diff, this is the core of it. There's a little bit more setup, but all it does is CDs to mount scratch, which has been set up as just a place where you can bind things. It binds the two places to the right place and then does diff-u. And hey, in Torvalds Git, there is thousands of lines of code wrapping around how do we actually diff these trees. Here, yeah, we've got diff, just use it. Tool-based approaches. This is kind of the bread and butter of Unix. And file systems really do that. Really do kind of make this sort of thing easy. Git revert. Again, I've only copied and pasted the core, but you get the clean name, etc. You basically figure out what files you're trying to revert, figure out where they live in the repo, figure out where they are relative to your current working directory. This is a kind of a messy thing. And then, sorry, I did miss one more core piece, git walk. Git walk is basically something that figures out, well, it's semi-core. You could do it as a shell script, but what it does is it looks at the files in your current working directory, the files that are checked in, and goes, these ones are dirty, these ones are clean, and makes it easy to say, hey, only walk through the files that are, only print the path, and only list the files that are removed or modified, so filter to removed and modified, on branch query with these files. And then just for every one of the files that is removed or modified, create the directory, copy the file from the tree, and then touch it so that Muck or whatever else will realize, hey, this file's been changed since the last time you built. The first version of Revert, by the way, did not have that. And I spent so much time being frustrated and wondering, why the hell am I getting out-of-date builds? Why the hell is it taking these old files? Yeah, and then git add basically just says, hey, if this file has been modified, mark it as dirty in the tree. And that's a little bit of a, that's a little bit of a hack around. So we've got an index, and this index contains a cache of the state of the file, the QID, so, and then the permissions. So if any of that's changed, or if it's no QID, then we look it up and we don't need to walk down to the file, open it, check if the contents are the same as what's in the Git tree, and that tends to be slow. So this is kind of it would be lovely if we could just do things directly from the tree, but this is a bit of a performance hack. You can just, and then the other thing is that if I do a git add, it adds it to the end of the file. So like, let's see. For example, and it should say, oh, well, it should say that I added this file. I probably screwed up something. Oh, well, am I in the right directory? Yeah, I'll figure that out later. It's not important. But you can just add to the index. It's just a flat file. It does get sorted when you do the git walk. But that's just, again, for efficiency. Okay, so how do you, what's the command? So this is just kind of a quick summary of what the differences are between plan9 git versus 9front git. So git init, well, it's git init. A lot of the stuff is you just put in a slash and you get something very similar. Git config, you edit the git config in your editor. There is no tool for that. Git pull gets turned to git pull, git fetch gets turned to git pull-f. So for fetch, git merge is just git merge. Git diff dash dash cache is git diff. There is no direct equivalent to git diff because git diff does something that's entirely asinine. And that's because Git has this thing called the staging area, and the staging area is entirely asinine. There are people that have different opinions. They're wrong. The very short summary, there are things that are nice to do with Git with the staging area, like committing just a single change from a large file. Oh fuck, I have a typo. The rest of it, this isn't ready to commit yet, but I should really push that one little typo. So git add -p or git is something that people will sometimes use, or git commit -p. We don't have this done yet because nobody's really put in the work and I'm lazy. But we can do better with something like a shadow FS. So you basically what I would do if I was building this for plan9 would be have shadow FS as a general purpose thing, shadow the clean repo, and then just use, what was it? IDiff to pull in the hunks from the dirty repo that I want to commit. Shadow that, and then commit that shadowed version. And now you've got something that gives you the benefits of the staging area without needing to put in the stupidity. So that's that. There's a lot more, which again, I screwed this up, so I apologize again. So, what does the workflow look like? If I'm hacking on things myself, well, I'll do exactly what I did here. I'll bind disk plan9 front to slash. I forgot to mention. So Git in plan9, in 9front at least, isn't just used as our version control system. It's also the way we distribute updates. So sysupdate. Sysupdate is just a little shell script that figures out the branch, makes sure that you're in the right place, and then just does a git pull. Nothing crazy here. So, oops. Then you commit the files that you're changing and push. If you're not confident enough to just push it, and you want some code review, well, we've also got some useful little scripts. So you can bind, you can hack, and then what you do is you do git diff and then mail it to the 9front list, or git export it. Either way, both work. And then on the other end, when I want to import it, what I'll do is I'll just bind the repo into the namespace, run upasfs, and then git import. Git import knows about the structure of upasfs, so I just give it the mail ID, and it'll pull in the repo, create the commit. And you have a really nice workflow for code review, for mailing patches, for shipping stuff around. You can also do something along the lines of either way it'll work. And this is how if someone's not wants some review, or if someone wants to send a patch on the mailing list or send some changes to 9front and they don't have commit access, this is how it's done. It's easy, it's simple, it's fast. There's no futzing around with well, there's very little futzing around with stuff. Yes.
Yes. So presumably, one of the nice things that occurs to me looking at this is that code reviewers on this one, what we really want to do when receiving things is you want to try them out.
Yeah.
And rather than just look at it and say, well, it looks good to me. But the computer disagrees.
Mm-hmm. Sorry.
This is a nice way of separating them.
Yeah. If you want to just test it without committing. And then the other thing here is that Git, the Plan 9 Git, actually has a few small tweaks to the way that patches get applied that make it easier for you to run with local changes, or to just import patches that have already been applied. So what happens is, so in Torvalds Git, what will happen is if you've got local changes to a file, it'll complain and say, I refuse to change this. In Plan 9 Git, what we'll do is we'll actually do a merge of the files. So you'll get, so if you try to apply a patch so that, or if you try to pull and there's already a patch that makes the same changes to a file that you've got patched locally, well, it's just fine. We'll just merge it in. Everything works. And this is, again, because the way we use the system, we tend to have a bunch of local patches that, hey, I want to have Sigrid's, well, I don't want to have it, but someone wants to have Sigrid's Rio theming. Someone wants to have, my tweaks to how, actually, what tweaks have I done? I have all of my local changes that are probably broken, or the changes to integrate GEFS into stuff that aren't ready to push yet. And when that does get pushed, the systems that have it locally will just work. Okay, so yeah, I wanted to talk about how I host it. I'll talk a little bit about that. And then, yeah, the last thing with hosting. So this is, let me just log into one more system. By the way, is this font size good for everyone? I should have asked long ago, but fine. Okay. Oh, sorry. Sorry, RC. Oh, fuck. Okay, so with Git, basically, there is so there's the unencrypted Git protocol, where basically this is the way I set up a Git server for unencrypted Git. Hash pound bin RC, and then I exec git serve -r the path to the Git repository. And that's basically the base where we start searching. So that's the way that hosting works on GitHub. There is an extension that I would like to get to upstream Git. I've also got the OpenBSD Game of Trees implementation of Git interested in this, which is in 9149. The same thing, except we wrap it with TLS serve and get encrypted Git protocol. So this is completely unencrypted Git. Encrypted Git lives on port 9149 for us, and we can actually serve Git over TLS without auth, so anonymous. And then finally, I think it's this one. Oops. this mouse is not the best either. So where we basically do TLS serve -a, and that tells us to use Plan9 authentication to allow Git to or to set up an encrypted tunnel. So this is the config for getting DP9IK, and the -w allows you to write. So if you authenticate with DP9IK, you can push to the repos in user-git. And everything there happens with the standard Plan9 permission. So if you auth as Ori, you can push to repos that have the file permissions that Ori allows you to write to. And this is everything I need to do for Git serve. Small little sneak preview here. The Acme certs are used for the TLS stuff. So we have a little honest ACMID, which lets us basically pull the Acme certs for serving TLS. So I think setting up Git, as long as you're not trying to do the web interface stuff, is I think Plan9 is the easiest system to host Git from out there. If you do want to serve the web interface, you just set up, well, the way shithub works is there is a TCP/80 script which runs the execfs with some Git rules to cat the repo using a shell script, and everything there just kind of is an RC script. So, and this is how our web UI works. Oops. So you get things like, I'll just do the view raw because it's tiny. Oops. Or actually, let's see. Oh, actually, tar. Oops, tar. So tar basically sets up the repo namespace, which is just a little bit of protective sandboxing. So basically, we bind it so that as little of the repo is available as possible outside of this namespace. And then we just kind of either we resolve the reference or not, and then we just tar the repo and gzip, pipe to gzip, and that's how you can grab a tarball from the website. You get similar stuff for like you get show, which has a bunch of like HTML, and then we cat the commit message, the date, and the author. All of this is just stuff that we grabbed from the file system tree. And hey, this is how we serve Git. This is our Git web. And I want to thank, by the way, I want to take the time to thank Phil9 for doing this work so that I didn't have to. This is mostly not my code, the web UI. Okay, so I think that's basically it. The talk title up here says I should be asking for questions. So, questions.
Two questions. So one, checking out random hashes. There is no git checkout command. Yeah, I checked. So
create a new branch.
Yes,
give it a minute.
But it took me like a good hour to figure out how to properly check it out. So maybe just, I don't know, have a command, or maybe just a note in one page that this is how you check out stuff.
Yeah, okay.
And the second one, yeah, I guess, would you consider backporting this to legacy? Like legacy?
No, but I'm happy to take patches if someone else does it.
Right. Okay. Thank you.
So for hosting Ninefront, how do you deal with Git's like kind of anemic metadata on files? Like file permissions, the appended locking bits on files. Like how do you deal with the fact that the Plan9 tree has those Git?
It doesn't seem to have that many of them. I don't think we've really run into that as a problem. There have been places where we got the permissions wrong, but the other thing is that if we mostly store the this source code, and then if there's things like the silent removal of empty directories. We'll have a script like root stub that'll put them back. It kind of sucks. And actually, the empty directories, I've got a plan to. It turns out that the repo format allows them. It's just the Git UI doesn't. And I see why. It's a little bit of a pain to say, I want to add this directory, and wait, do you want to add the directory, or do you want to add the files in? And most of the time, 90% of the time, you want to add the files. So having that kind of distinction with the command line flag or something is a bit of a pain. Actually, I just had a thought. You don't necessarily need a command line tool to deal with it all the time. You could just, I could just add a flag to Git, or I could have Git save do the directories, and maybe you just fall back to the raw thing when you need to create those directories. So Git commit knows. Yes.
So I was wondering if that on additional metadata, a lot of that's handled by the NFS copies. You have a bigger file as opposed to the metadata destination. So we make ISOs or you install one that does that actually says everything in syslog is by default depend only, and that's how it works.
Yeah. I'll just repeat the answer because I don't remember if, I don't know if that picked up very well. It was kind of quiet from the front here. So basically, when we create the ISOs, the makefs tools will also just change the permissions to what they should be in the tree.
Is there any appetite for having Git9 vector on Unix? Using the same interface, or
Again,
inner slashes?
I'm not going to do the work. The code's there. The code's actually, so Git of trees, the OpenBSD Git thing, is, well, their interface is very, very different, but they have stolen a bunch of my code. So it's a friendly steal. So I encourage them. But if I look through the, for example, I don't know, the pack file parsing or the protocol code, oh yeah, they've changed the names completely to match their style and their taste, but the structure is kind of similar. Yeah, I'm familiar with this. Also, God damn it, grow your vectors exponentially. So anyway, the code can be ported. The file system approach, maybe you could do it with Fuse, or maybe you could do it with NFS or 9P. Good luck.
I'll take NFS.
Yeah, feel free. Fuse might. Let me know how it goes.
Yeah.
Again, it's one of those things where, yeah, do what you want. I'm not doing it. Anyone else?
Just, I'm curious. I couldn't quite figure out. Would this make the work trees stuff they did easier recently in Git? I was trying to figure it out, and I can't figure it out.
I think so. I mean, it's basically going to be binding the repo into the work trees a few times, and then you just you bind the object store, and then you have separate metadata. I think that would be all you need.
But you can do commits. The work trees are writable. With that, you'd still have that, right?
Yeah.
Oh, that's great.
Because of the way that everything's a Merkle tree.
Yeah.
The only thing you have to worry, every object is just kind of completely separate. There's no worries about things stepping on each other's toes other than the metadata. So the branch names, the head object, the head file, and the git config. And even the git config you can bind it.
Yeah.
You're not changing that very often. So it feels like you can just, a work tree would be a tiny little script.
It's seen that way.
Yeah. And I'm thinking, if I was implementing it with Git 9, I'd put the work tree in the git config, and then just have, so there's a little bit of a utility script that every git commit syslib common.rc, and in common.rc we have a little function called getup, which figures out the root and sets the file system and so on.
Oh, okay.
We could probably have it do something along the lines of if
Yeah.
something like that.
Yeah. Just another, because the
Yeah,
amount of junk they added for work trees looked pretty horrendous. And
yeah.
this is like showing that you get the same behavior at the cost of very little work, which is kind of neat.
Yeah, I think I've implemented it. Uh,
But yeah,
I think that's the implementation.
yeah. Very nice. Yeah.
And then you just, the work.repo, you basically have something in your commit that, in your git config that looks like.
Yeah. Jeez Louise. Yeah.
I think that would work.
Yeah. Nice. Very, very cool.
Is that also not an example of how laziness is very helpful?
Yeah.
Is it, who wants to do thousands and thousands of lines of code? Oh,
You know what?
I'll just
I
arrange
think
the structure of the thing so that a few lines of shell will do.
I think the laziness is in writing thousands of lines of code, and the hard is doing this. Honestly, people just churn out the code.
I mean,
It's hard. It's easier than thinking about it.
hey, I'm sure that someone was paying for it, so that you have to show that you're doing hard work.
Probably true. That's true.
Yeah, I couldn't justify a month of salary for that. Yeah.
You mentioned in one of your scripts that copying one file from one directory to another was not sufficient to get Mud to know that it needs to be rebuilt.
Oh, we preserve the timestamps and Mud looks at the timestamps. Yeah.
In copy.
Yeah. Or at least there was a flag that was used to preserve permissions, which also preserves timestamps, and that was the dumb mistake. Okay, I think I'm not seeing anyone else with hands up, so yes.
You mentioned Venti in the beginning. Do you think there'd be any benefit to just putting it directly on top of Venti, just using it as the object store?
I think that would be,
Compatible hashes.
yeah. You could do something that worked very much like Git, basically take all of the scripts and the tooling and make it work on Venti, on a Venti-based thing where you have the Venti score. And I think that would work well. No, do you know if there's a limit on the blob size in Venti?
51K.
51K?
It builds up the tree, so if you receive that, you just build up these almost smaller blocks.
Yeah, I guess you could probably point it. You can use a BFS and point it at the Venti root score, or something like that, and that would give you the tree that you're trying to mess with. So yeah, you could definitely build something like this on top of Venti. As I said, one of the big motivations, especially initially, was I want to clone a Git repo, and Venti doesn't help me. On the other hand, if you wanted to do something native Ply 9 and you were ignoring the outside world, I think Venti would be a good tool to build on top of. Okay, I will leave time for the next person.
Just some minutes.
To be honest, the audio was not perfect now. I'm not too happy with that. I will see if it's off the mic or I'm not sure.
Yeah, there was some complaints about the durability of the audio combined with those speakers in the room. Talk about that. I don't, how we get away with those,
Yeah, I can just speak up. Yeah. There should be a power button.
Sorry, that's interface.
Yeah, I will put that in. And you're good, you'll
Because
just
you just run
Yeah, I
down.
will do another check now.
Okay.
Load monitor.
Okay.
So the app says.
All right, this is a check on the audio. Another check, another check. When I keep on talking, does it sound weird, doesn't it? It seems okay. Okay. That was my mistake. Okay, we actually have it here. Okay, turn it off.
Okay, we still got her
Okay.
there.
Yeah, audio is still working fine.
Okay. The only thing is we'll have to turn that back on if when we do the recorded presentations.
Yep. All right. So I'm seeing it here, and if anybody wants to open up YouTube, you will hear everything with like 15 seconds delay. Yeah, that was an intermediate image I was showing while doing the setup here, and now it should be back on in like 3 seconds or so. Yeah, it's a very significant delay. All right. All good. All right. Yeah. So hi, I'm Daniel, and I would like to talk about some controversial stuff today, which I hope will make you all happy because that's what we're here for. I took this title here, Center, Left, and Right, and if anybody has heard of Center, they might know about one thing I'm going to talk about. And what I want to do is I want to go beyond a few things which have come sort of stereotypical, hence the secondary title. The acronym you see down there, I also do lots of fun things, not like GitHub, but I came up with the Institutional Academy of the Academic Institute. If you go to iaota.institute, I even got a website, and I got a logo, so I'm all set. It's how we do things nowadays. So I will just briefly talk about a few things. First, I'm going to break some traditions. Then I will talk about something I'm doing and stuff I'm doing, where I try focusing more on protocols again. And then I will do a brief derailer toward Rust and WebAssembly. And if you don't know anything about it, I will give a very brief intro. It will be very simple. So to break traditions, how do you do that? I will start with a magic trick. And I will be doing this. I will just step on everybody's toes here, right? Without even touching you, just by standing here and talking. Who knows this scene here from the Batman movie? I'm seeing a few hands. So this is the Joker. He's performing the pencil trick. Okay, the pencil trick works as follows. One of those guys there is standing up, coming toward him, and he is then smashing his face on the pencil, and the pencil disappears. And he says, "Ta-da! It's gone." Right? So that is the kind of trick I'm performing here. Anyway, so yeah, if we recall, how did computers start? Essentially with research, right? Just like every sort of technology, it's like grown in a lab somewhere and escaped. So, yeah, but what was it actually invented for? It's a bit hard to answer. So I just found that there is a huge focus on bureaucracy in terms of computing. So when we talk about computers, out of a sudden we're talking about all this imagery from literally offices where we have forms and files and folders and all that weird stuff. Business processes, as some people say, administrative work is a very, very huge burden, right? Everybody knows what happens when you set permissions wrong. Things either don't work or everybody has access to everything where they shouldn't and all that stuff. That is not very great. But, well, whatever happened, we got computing everywhere now. It's so ubiquitous. We can do it like, everything is computing, right? So we have applications in all sorts of things. Can be medicine, can be military stuff, civil services, anything you can think of, like all the gaming, the entertainment industry now. Everybody's personal life essentially depends sort of on computing. So, yeah, but can we still do something? That is always a question. So I want to come back to research again. And when we actually look at Wikipedia, well, the very first sentence is that Plan 9 actually came from the Computing Science Research Center at Bellops, which is apparently not too far away from here. Torn down since, as you know, but yeah, let's get back to that. So I know that there were very, very nice results that came out of that research, right? So there are many things that we're doing every day now that we really like and so on. And there are some ideas which have actually been ported around. Like, every system nowadays has some sort of idea from Bell Labs that entered their space, right? So we have namespaces on Linux, for example, not exactly the same thing. We have a bunch of stuff, right? So yeah, but that's okay, right? So we can still think about things. And there is one thing I want to focus on a bit more, and that is mostly interfaces. And interfaces, it's also a very generic term. But yeah, I'm also talking in a generic manner. So people think about simplicity often when they design interfaces, right? And here's one culprit. It's easy to create something that is hard to consume. So those are two very, very separate things always to keep in mind. Disclaimer here, my day job is actually application development, mostly on the web, also a bit on mobile. And we think a lot about actual users on the other side and how they might actually consume something that we create. I notice there is this term that is still in use everywhere. It's API, an application programming interface. If you look closely, often it's not about applications at all, and not even programming sometimes, right? It's a bit weird, but still, we have interfaces. There is this one thing I always found weird about file systems. So, I can echo something. I can redirect it to a file. That is a very, very classic Unix thing, right? So now I have a 1 in my file called foo. Okay, it's not very exciting. It's like just writing. But I can also do this here, right? So I can also interact with a file system, and all of a sudden, I get side effects in hardware. And if I think about the concept of a file that doesn't actually translate to the physical world, right? To turn on the light here at the ceiling, I wouldn't write down something and put that in a physical file. That's not how that works. So yeah, I'm not sure why I want to call that thing a file system then. But yeah, I get that. It's a historic thing. So now this here is funny. Who knows what happens when I open the file dev.null in my editor here called Vim? Any idea? I will briefly show this because I found it funny. So who of you says Vim? Who of you says dev.null is a file? More hands, more hands. It's in the file system, so it must be a file, right? Okay, so what Vim says is dev.null is not a file. Sorry. What happens if I write something to that file? It's gone, like the pencil trick. Anyway, so yeah, I find those things a bit awkward. And that is what I want to rethink a bit. That brings me to thinking about the command line interfaces that we have. There's this thing called POSIX. We're also going to hear a bit more on that in a bit. And there are some things people came up with to sort of standardize, right? Like design ideas and stuff. So yeah, let's look at a few things. There is a very nice tool for downloading files that is called wget. There's another one that is called curl. Both are doing this one thing. Are they doing it well? Hard to argue about. So, I mean, wget is mostly just for downloading files, right? Curl is mostly like implementing all sorts of network protocols in a way, like very, very many ones. You cannot just download files. You can also do, I don't know, you can do post requests. You can send JSON encoded data with it, and all of that stuff. And I think there are so many protocols implemented in curl. I think nobody would just be able to enumerate them all, except for Daniel Stenberg, who wrote the tool. But you get the idea. There are different ideas of the default behavior of those tools. One of them would write to std out by default. The other one would write to the current directory and create a file for you, using a name that is part of the URL just by default. Okay, so some different ideas. But both also have a way to specify an output file. One of them uses -O, the other one is lowercase o. For whatever reason, you sort of get my issue here, right? So if you are not very familiar with those tools, you might get very, very confused easily. Here's a fun little thing that we just had recently in the open source firmware community. What is the meaning of a single dash in a command line interface? I looked that up because I was mostly thinking that would actually mean you read from std in, right? Turns out there is a guideline in POSIX that is saying for utilities using a yada yada single dash should be used only to mean standard input or standard output when it is clear from the context. When is it clear from the context? Let me give you an example. Let's take wget. When you use wget and you give it a dash, does it try to read a URL from std in, or does it write output to std out? It writes to std out, right? Learned that, but it's not what I would have expected from previous experience with other tools. Anyway, yeah, I don't want to, poop on everything here, right? So I'm just saying that there are a bunch of things I would like to, get back to the drawing board for. And that's why I want to focus a bit more on other things again, which is mostly protocols. So you've heard of this thing called internet, right? So we're all connected nowadays. Some people wanted to put everything on the internet for whatever reason. I would like to remove things from the internet mostly and just, I mean, we can put things on a network that can be fine, can give us some benefits like, I mean, we have things here now being on a network to do our live video stream and stuff. That is very, very nice. It also goes out to the internet. But yeah, it's mostly just about shoving data around. So what I did was I bought a bunch of gadgets. Does anyone have any idea what the heck this here could be? Very close. So you see those tiny clouds in the background here, right? So these are all similar devices. That one here is plugged into a USB port. That's not actually a laptop's USB port, but it's just a charger. And what this does is it opens up a Wi-Fi hotspot and will expose files that are stored in it. So it's like a USB thumb drive, except you can also use it over Wi-Fi. If you connect it to actual data lines on your laptop, that would show up as a USB storage device. Fun stuff. So yeah, what I did with that is, I mean, it wasn't really hard to break into it. So I took a tool that we have in the open source firmware community that is called uroot, which creates your root file system. I just put my root file system on it. I just wanted to see if that works actually. So that the thing is based on MIPS. Was easy to compile for. That was actually my first attempt of putting uroot on something that is not x86. Funny, and worked. Okay, so another thing I found this year, it looks like a hand grenade. It's sort of close to it. It's a portable Wi-Fi router. It's a charger, so like half of this thing is a battery. So essentially everything down here is just a giant battery pack. Up here, we have a sandwich of 3 PCBs, and that makes up this whole weird contraption. You got card readers for, like, I don't know, SD card and all that shit. And because I needed it, there are wires now for the UART. So, yeah, I could happily connect to that. And I just put OpenWRT on it because, whatever the vendor put on there wasn't too useful. And of course, what I could do at some point, and I will get back to that, I could see view into this thing. I will show you later how. Now this here, you see there is a lens on this, right? So this here is a camera. It's a bit open right now because once again I needed wires to get the UART here. And this here is supposed to be a doorbell camera. So it's a bit like, this, what is it called again? Ring, I guess, right? So it's part of the whole surveillance stuff, but you could also technically use it in a beneficial manner for yourself. Like when you connect it locally and not to, I don't know who. So yeah, that is very nice. You could also put your own system on it and just connect it locally. This here is, again, having wires coming out of it because I wanted the UART. And the actual purpose of this here is to serve as a TV box. You get a bunch of those, very, very cheap, I don't know, 15, 20 bucks or something. You get them on Amazon, AliExpress and stuff. They're usually not very well maintained, so you would get an Android from, I don't know, a few years ago. It worked for a while, and you might actually get malware out of the box with that because some people found that, some of those boxes have whatever stuff pre-installed. You will never know unless you run your own code on it. That's why we have those wires. This year, another fun one, and you see wires again because I guess you understand the pattern by now. I could just run my own code on this thing here. It's now showing the RISC-V logo. It's based on a RISC-V processor I've worked with. And it's actually meant to be for, for your car. You just put it in the front, and then you would just mirror your screen from your phone on it. You can use it for like navigation and stuff. It's called a car media player. I mean, nice idea. And that is actually a very, very local thing now because that is really just doing local exchange, right? So yeah, Anyway, so yeah, I want to see if I can just repurpose all of that stuff here and build my own network of things, not the Internet of Things. So there are two tools that I'm using for this stuff regularly when I'm working on it. Those are Sender and CPU. Sender is a tool that we got from the Harvey operating system project, another Plan 9 implementation that you may have heard of. It's actually the first one I've run into when I did my research and saw, hey, there is actually still people working on operating systems. Okay, what do we have? Okay, I found this thing called Plan 9. Okay, at that point, we didn't yet have Plan 9 Foundation. It was very hard to find actually information. I never knew what was current or what was already, I don't know, semi-archived, lost, or whatever. I mean, now we're here. I'm good now. But yeah, at that point, yeah.
It serves 9P as well.
Yeah, it also serves 9P, as Ron just said. Okay, I'm sorry. Yeah, anyway, so what I'm mostly using it for is just DHCP because, things on the local network. If you don't want to, I don't know, set up your home router or something, you just want to have something local between your laptop and your target device, just do a local DHCP. It's very easy to do. TFTP is what many devices actually use for booting, so many bootloaders have that implemented by default. So when I, hook up to my UARTs, I can easily switch to that stuff. I'm rarely using HTTP from Sender, but yeah, it's also available. And speaking of available, it's on GitHub, it's under Harvey OS, it's in the repo called Go, and under that you will find command/sender in the directory. All right, so CPU, everybody knows CPU, right? That's Plan 9 after all. We were talking about the other one. That one works on Linux, so that is what Ron actually did a bunch of years back already and talked about it a bunch of times. It took me a while to understand it, and now I do. So yeah, we have a CPU now, which I can just use to connect from one Linux machine to another. And I learned, well, it's actually really just like SSH, except I don't need to copy around my files. I just get them mounted immediately. Very, very simple idea. So what did I do with that? I took another look at all the gadgets I got. I exchanged a bit with Ron, and we put it on this thing. What you see here is another incarnation of so-called wireless cameras or IP cameras. Yeah, this body here in the middle, again, you see the wires coming out. That's the UART again. That thing has run CPU over its Wi-Fi. It doesn't have too much memory, so it just barely worked, but it did work. And that was very cool. So yeah, I could just use something like, I don't know, I could look at procs, whatever stuff, right? So that was very nice to do remotely. And I could just then use my local tools for further processing. Very neat. I talked about similar stuff a while ago at Chemnitz Linux Days or Chemnitzer Linux Tage. If you're interested, that talk was also in English, even though that's a German website. Yeah, feel free to take a look, and that is where I focused a bit more on one specific gadget, which is actually a camera, and also gave a live demo on this stuff, which I'm not doing here because we're a bit short of time. So yeah, as I said, I'm mostly working on the web actually, and as you know, the web actually started as a platform for documents, right? So people just wanted to serve documents all around, well, at CERN at some point, but then on the internet, like everywhere. That is very nice. So now we can easily exchange information. And then it turned into a platform for applications. So what I can do now is I can claim to be a document, but I'm actually an application, which is, from my perspective, very awesome to have. And if you think about it, it's actually not even a new concept. That concept has just literally been translated from each and every platform to another. So it's always easy to just display something. Turning it into a meaningful application requires a lot of design thinking. So I want to embrace that. I want to see if I can take things that I know from the web, that I know from operating systems, connect them a bit again, push things further down, which are currently very, very far up a stack. So yeah, I'm just proposing a few things here now. So whatever I'm talking about here, that's my disclaimer. There is no implementation of this. I'm just talking conceptually. I want to do the following thing. I want to use WASM, or WebAssembly, which I will come back to if you don't know it yet. I want to be able to put application code on any remote gadget that I have around me, like my wristband here or whatever, camera, can be anything, and just run it there. And then just serves me back. And when it serves me back is, well, it can be another application again. Which means that the device I'm putting an application on knows how it works itself, so I don't need to have any special purpose application on each and every machine that connects to it, because I can just get the application from it, which is, speaking of the web again, exactly like when you visit a website today, like, I don't know, Amazon or something, right? You're shopping on Amazon, and there is actually a small application running on there, which is like, I don't know, giving you search results or recommendations or whatever is happening. Or you go on YouTube, right? So YouTube, it's not a document, right? It's actually an application. So that is giving you a video stream or something. You can chat with people on there. So yeah, I want to see if we can bring that concept on other machines. Well, so what we can do is we can make use of some existing runtime environments. Like, you know, we have the web browser already. I could put something on a gadget, then go somewhere on my web browser and connect to that gadget through the web browser. That already works. I could do simple protocols. I can use something like, who knows, Regis from like the 70s. Okay, we're not old enough here. Maybe a few of us are. So what they did was they came up with a serial protocol to just draw graphics. So you would use your terminal, you connect to some mini computer, you know, the fridge-sized thing, and that would just give you serial commands to draw vector graphics on your machine. And since I didn't see too many hands, I actually prepared a small demo for this. So this here, yeah, it's a recording. Anyway, I'm just going to play it back. So this terminal rendering here, this is from Xterm. I'm just printing something over serial now, and now I'm switching modes. Now I'm switching to graphics mode, and out of a sudden, you see I can do colors, I can do flashing stuff. This is a demo I created for a demo scene party called Mountain Bites earlier this year. Yeah, I figured this already started in the late 60s. Still works today. So yeah, I can do all sorts of fancy stuff. I can do this. I can draw circles, lines. I can do animations. I can draw vector graphics because this is all vectors after all. This is a VT340, by the way. I can draw the RISC-V logo. And, you know, draw text and stuff. So yeah, that was the demo. Why not put that on my gadgets, right? I can do something like that and claim the gadget is my mini computer, which is actually a small thing right now. Connect to it, see something on my screen. That would be awesome. So yeah, what we can use, as I said, is something called WebAssembly. That is a second runtime that we have in the web browser today. So we have the JavaScript engine and we have the WebAssembly runtime now. Everything can talk to each other here. Not like, you know, all across domains and stuff. There is still some security in there. But what I'm saying is, you know, it opens up some doors. So what you can do with that is you can run what we would call native code within your web browser. So we can just compile it to a different target. It's yeah, useful in all sorts of scenarios. I've seen papers on, you know, people putting that stuff, a WebAssembly runtime itself, already on microcontrollers and whatnot, right? It's started being used now for Kubernetes stuff, for example. There are runtimes now which just execute WebAssembly. So you don't need a full application container with I don't know what in it. We can just give it a very, very small piece of code. That would work. There's this thing called web serial. I can use a serial port from a web browser now. That just works, right? So what I can now do is I can now go ahead and, you know, define some specific protocols for whatever application I have, and I can bring that to any environment. It works in my web browser. It works on a very, very simple microcontroller. It's very, very portable. And of course, I can't leave you without showing another demo with that. So I'm connecting something here, which is a USB serial converter. But this one here is a bit special because it has multiple serial ports. And I prepared something here. No, that is email. I'm sorry. I prepared something here where I can now connect to this. I will connect to a UART, which is somewhere up here, that one. So I'm now connected to this UART. And I'm also connected to another one here. Now I crossed the TX and RX of those two. So what happens now when I type here, I can say hello, right? That works. I can also turn on local echo so you see that I'm actually typing this here. Plan 9 is awesome. Oh. Yeah, backspace isn't working. But you get the idea. We're missing the S here. I'm very sorry. But you get a smiley face instead. All right, so yeah, that works. And yeah, as I told you, some people have already put WebAssembly runtimes on microcontrollers, and they called it WASM-led for whatever reason. If you know this LED thing, there is like many ways people just put small binaries somewhere, and they call it a something LED. It can be a sys-LED or a surf LED, an app LED, all the LEDs you can think of. Just means something small after all. So WASM 3 engine is one of the WebAssembly runtimes that we have that is portable to, all sorts of platforms. So now I'm thinking, okay, if I want to connect everything together now, I would need a nice environment to, launch my applications, connect everything, and so on. And well, I'm looking at my phone here, and I'm saying, well, the phone has a very nice app launcher, right? So you open this thing up, and then you have like all your apps that you have installed. You can just open them right away. I would like to have something like that. We know desktop icons, they are very similar in that regard, right? Like on a classic, I don't know, macOS or Windows desktop, right? You would have an icon, you click on it, and it opens an application. So yeah, why should I not just be able to draw an application launcher just like with draw term? I would, instead of connecting to a remote whatever machine, and then just using something textual, I could also start an application launcher and then launch an application on that. So yeah, and if I wanted to make it touch friendly, I also thought about that. I mean, we can just use gestures, like, I don't know, use your 3 fingers, draw a diagonal, that gives you a rectangle, right? And then you can have your application in that. So like, here, applications 1, 2, 3, whatever, just tap on one and go. Yeah, again, this here is still very, very conceptual. Nothing really implemented yet. I'm just presenting those ideas here. If or not this will ever be implemented, we will see, but I hope so. Now, I just want to speed things up here now for lack of time. I came up with a project where I wanted to actually think about everything, in a bigger context, and that includes not just the operating system, but also the hardware below, the firmware between, and all that stuff. I call it platform interface, platform system interface. I gave a talk on that. That was unfortunately in German, but the slides here are in English. So yeah, if you want to take a look at a bunch of ideas I presented there, yeah, go have a look and check it out. By the way, I think we will have some way to publish all the slides later. So yeah, we will just put them on the IWP9 website. Then you can just follow those links. I already showed you the demo, so I'm skipping this slide here. I will come back to this REST and WebAssembly stuff because I want to show you how easy that works. So it really goes like this, another magic trick. We compile REST to WebAssembly and use it in our application. It's really that easy. It's just magic. So to get started, there this blog post and the documentation for REST WASM that get you started very easily. Here's the TLDR. You just install something using the REST tool called Cargo, and that thing you install is called WASMPack. WASMPack is a command line tool again, and that creates you a new project. Off you go. If you want to glue that together with like, a fancier web application around it, that's how you do it. Just follow those tutorials. And then there is something for more like data marshalling and stuff that is called glue utils. Highly recommended. And that's all you really need. And here is now a small excerpt of Rust code. That is really everything you literally need to write for doing this. So yeah, glue utils, as I'm saying, is something you can use. Certainly as a tool for serializing, deserializing data, and then the WASM bindgen stuff. You would just include that. Here's a struct I'm defining. I'm using this here, the derive thing. That is something in REST that just easily lets you add your additional stuff, like automatically creates you the serialization and deserialization, so you get methods like this stuff here from Certi. You can just use that right away. So down here we have some function. It gets this other annotation here, which is wasm bindgen, and that will just expose it to a WebAssembly context. And now all of a sudden, this here will compile into something I can just call from my JavaScript code that I run just side by side. And that looks like this. I import it. Just by default, the naming would be something /pkg. That is like, where the WebAssembly output goes. I would just call this function. I'm sorry for the dark and dark here. Anyway, I can give it some arguments, and I can get the result. As easy as it is. This here is now synchronous and blocking, so never mind. Of course, people also thought about that. So if you want to look further into it, that's all you need. And with that, yeah, thank you very much. Yeah. Yeah, I already have a copy of the slides on my website, actually. Anyway, I hope I was offensive enough to provoke some questions. So, any questions? Yes.
You mentioned bureaucracy at the beginning of the talk.
Yes.
If I remember correctly, the first users of Unix were the patent office at them that used Unix for typesetting. So bureaucracy was very close on research.
Oh, right. Okay. I hadn't known. Okay.
They justified buying PWL.
Okay. So patents all the way down.
That's also why there's an option in T-ROC to produce numbers at the front of each line, because the patent applications have to be numbered that way.
Right. That's called smart marketing, right? Because they found a user that had to have it.
Yes, I don't remember who came up with, who realised that this would be a pitch they could make.
Yeah.
I have a question. So do you happen to know how big, you talked about putting the WebAssembly runtime on this, for instance. Do you know how big that is in lines of code I mean, years ago there was a thing called intercode that Martin Richards used to distribute BCPL. There was a thing called O-code, which was sort of a tree-like structure that you could use to do a new code generator. But that made porting hard. Intercode at the time, if you look on the website now, it's rather more complicated. Intercode at the time had several handfuls of operators, and you could do it simply in a small switch statement in C to be able to run the BCPL compiler to be able to bootstrap itself.
Right.
So WebAssembly, I suspect, is rather bigger than that. But how big is it, in lines of code and to run WebAssembly programs?
So, I mean, there are multiple WebAssembly runtimes, at least like, I don't know, 10 or something. So yeah, they might be a bit different in terms of like what exactly they support, and also like, I don't know, lines of code. I don't know, I haven't looked into that. I mean, the effective question would always be, is it small enough if I want to run it in a very constrained environment, like, I don't know, a microcontroller with 16 kilobytes of RAM and, I don't know, 8 or 32, up to 32 kilobytes of RAM. So that is sometimes what we're dealing with today. So yeah, that is where, things might need to be squeezed down a bit. But yeah, I haven't really measured anything so far. Yeah.
Well, knowing that there are that many instances of different implementations of it is interesting.
Yeah, absolutely.
It's perhaps suggestive that it might not be that.
Right. If anybody wants to look into that, Stefan Valentowitz from Munich has done some research on that, and they published something where they actually compared, like, I think 4, and also mentioned another 5th runtime, because yeah, they wanted to see if that can be used for an industrial application somewhere and stuff. Yeah.
What did you end up doing with all those pieces of hardware that you showed us?
What I want to do with all that stuff?
What did you use it for?
Yeah, so far I'm mostly just playing around with stuff, right? So there's actually a bunch of folks who are doing this home automation stuff, right? So they would usually set up something like Home Assistant or something, and then use the vendor-provided stuff for integrating things, or I don't know, flash their own software on an ESP32, like one of the well-known reference SoCs that you can use, or microcontrollers. I mean, it can be used for almost anything, right? So we have like all the sensors and actors and stuff. So I'm not really after that. I'm really just about conceptualizing, and yeah, I want to see if I can actually come up with something new, maybe. I mean, I'm very, very far from being there, of course, but yeah, I don't really have a straight goal in mind so far. Thank you. Yeah.
So I keep thinking about how I think about it from Plan 9 angle, right? Mm-hmm. So all these little devices would run I think of them as running 9P servers, and then I would copy my WASMlet to a place on them, and it would make it run with Cuddle file or something. I mean, is that...
With Inferno, we had a demonstration with the Lego brick.
Yeah, and I keep thinking...
And that had its own tiny 9P implementation.
Yeah.
With some code also to do run length encoding or something across the limited serial port. And then someone at V2 built Chris built a Lego clock.
Yeah.
And it exported a namespace that allowed you to adjust the time and set the rate at which the clock moved and control the motors individually,
right,
to build something else. So the clock, I think, was a very simple program in Limbo that simply wrote two things imported into the namespace from the device.
But the nightmare with all this IoT junk, like I have a friend who spent a full day one time because his light bulbs and Kubernetes were now not talking to each other. So he spent a day getting his light bulbs one by one back. So the problem with all this IoT shit all the time is nobody wants to deal with it because it's so awful to configure. Mm-hmm. I don't know how any of this helps, but I would say it's not working very well today. And you read articles now where people say, I don't really give a shit about IoT. I just want my light bulbs to work, and I don't want to ever look at them again.
Well, there's also...
They're not there.
Because of the way they do it as well, by having a fully featured system on our side.
Yeah.
And often using HTTP and other stuff.
Yeah.
It exposes a huge surface, much, much bigger usually than they intended.
Yeah.
Whereas, again, going back to the Lego brick, it exported this namespace, and that was all you could see. You couldn't gain access to the stuff that implemented that, the stuff behind it, which was anyway tiny and couldn't do anything. Whereas this other stuff, it isn't just your light bulbs, it has access to your network and in rather more deep ways, or rather deeper ways than just controlling the light bulb.
Yeah.
I have a few thoughts on that, and that brings me back to home automation hobby stuff. So one thing is many vendors that offer these kinds of products, they're looking at the real world and they're saying, well, most people don't know how to set up anything, right? So they don't know about file systems at all, for example, and all that stuff. So they want to make things as easy as possible. And they're thinking, well, what everybody has is a phone, essentially, which is either Android or iOS, and that's what we focus on, right? So the eventual decision is, okay, but we still need to have the connectivity. What's the best thing we can do? Come up with protocols that work locally, so like the car media player I was showing, and I think like Google Home or something is very similar. It's like you would have a specific application that would then talk to the gadget over mostly Bluetooth for establishing an initial connection, and then would switch over to something like Wi-Fi for high-speed connection. And this is essentially how all of that stuff works. and it's mostly backed by some whatever cloud service, which is a very big issue usually because, as you know, cloud services, as clouds do, they just vanish over time. Sometimes they rain down on you, and it's very unpleasant, like, when the light bulbs stop working. So yeah, that is why I want to see if we can figure out something that always works and always works locally, right? So I want to get the network of things, not the internet of things. It is a very, very big challenge, especially if I'm thinking really in terms of products for real people. I mean, otherwise it would really just remain a niche of a niche of a niche. Like, home automation hobby is already quite of a niche, I would say. I mean, there is some, commercial stuff which is a bit easier to use, but, again, mostly backed by cloud stuff. Or you would have like a local appliance, but that only works with these and these gadgets. For another one, you would need another one, and it gets horrible again, right? So I think the best thing to do really is to shrink things down again and come up with better protocols for dealing with them. I know that there is a bunch of stuff going on in the industry. Like there is a protocol called Matter, MATTER, that is sort of being standardized. There was this thing called Zigbee, supposedly standardized, but I heard that it's actually all different again because, it's just how it works. Yeah, it's really hard to get to that point. Yeah.
So as you talk about putting devices on a network as opposed to using the serial port, then discoverability becomes important, right? So what do you think about that? Should it, Plan 9 doesn't really support those things. It's like,
logistics. What's that? The logistics. The logistics. You can. Sorry, can I check something?
Yeah, you have to.
The logistics. The best thing.
Yeah. You're talking about the files.
Okay.
NDB.
Okay, so you're essentially destroying the magic here, and thank you very much, because it's actually the whole topic. So the question is always, if you want to connect all of this stuff, how do you discover it? Yeah, so as I said, the current devices are often doing it over Bluetooth, right? So that's what people can sort of use quite well, but it's also something that when you develop an application, you can also interact with Bluetooth over the operating system directly. So you can do discovery over that stuff theoretically, but then again, it's always a bit vendor specific again, or application specific, right? Like, you would use a car, whatever app for setting up a car gadget, or you would use your Google Home app to set up a Google, right? And that's always a bit weird. So we would have this, some people call it vendor lock-in. I would like to be fair again. It's still very application specific then. So yeah, it's definitely something to still think about, especially because many things need to have a way to establish a connection, which might not all just have Bluetooth everywhere or something for the initial setup. So yeah, I mean, I popped open all the devices for a reason, to get my UART, right? And I think if we can come up with a simple protocol, so I just want to be fair here. I think 9P is a very, very nice thing. Maybe not the right tool at this point, though, right? So yeah, we would definitely need something for establishing, setting things up or something. And of course, do reset, right? Because if you want to sell something again on eBay, as people do, you always want to make sure that whatever data you left on there is gone before you sold it. Yeah. Right. Yeah, I think that should be it for now. It's time for breakfast. Lunch.
Lunch, yes.
Oh wait, we do have monitor and output, right? So when we have monitor and output, now when you just keep talking, sorry.
Monitor and output, let's...
Hang on a sec. I will do monitor off here, because then we don't get feedback from here, and I will plug it in here again.
Okay.
Which gives you a... So that gives you a delay of about 10 seconds, maybe. It's a bit weird, but I just hit live. Yeah, that was. Another to the right. And
How do you do it?
that one. So you should now start hearing things from that microphone, but with a delay.
Okay, let's see how the audio is.
Well, that's true, actually. Yeah. Really nice.
Test, test, test. Perfect. Okay.
That's good?
Yep. Alright, how to switch back?
It just mute. That's it. Just go.
We are computer science.
Hang on a second.
And every time something comes up, I yell about that.
Okay, say something again. Okay, hang on a sec.
They will only assign IP addresses.
So certain SSIDs.
Okay.
The different SSIDs have.
I'm not hearing anything just yet.
Okay.
Is it unmuted?
Yes.
What do I?
Is it up here? You see the yellow LED
It
here?
says not mute.
This is not here.
The hotel, oh, it's not just that. The hotels don't impose the same restrictions. You can't.
They say they can hear me.
Yeah, this one is
extremely. It's a standard university. Oh, no, let's protect the students.
You can't do things.
Yeah, you can't do things.
All right. Can you say something?
1 2 1 2.
What it boils down to.
Test.
There's somebody.
Test.
Okay, that sounds good. Good.
Okay.
Then I can justify my existence. That's what it boils down to.
Great. Welcome back from lunch, everyone. I hope you had a great one. And we're back with Jacob Moody now, talking about portability on and POSIX stuff. And there you go.
Okay. Welcome. So I'm here to present a talk about specifically what the current kind of future of portability has, and about both only kind of where we currently are with Plan 9 and where we're kind of wanting to move towards the future, and hopefully some interesting bits about kind of how we visualize that going forward. So right now what we have here is we have APE. And APE is a little bit old. It was written when POSIX was a lot more important to portability. The APE itself stands for the ANSI POSIX environment. What's interesting is it's more or less a parallel on top of our current existing libc. So it has its own syscall stubs, it has its own libc. When you link a program with APE, it does not touch our libc, it's entirely disjoint. That has some nice features to it. It means that it is more of a true, quote unquote, ANSI environment where you're not going to have symbols that are not defined as part of that environment typically, and allows a bit more of a clean room, so to say. It's not entirely compliant. There are bits and pieces missing that you find as you try to port software, but it's mostly gotten us to where we are now with bits and pieces being added. As Ori mentioned earlier in his talk, NetSurf also used APE, and they were able to use that to a decent advantage. We use it primarily for getting alien code, so code not written for Plan 9, audio decoders and GhostScript and old Unix stuff we run. We use this. So what are kind of the parts about APE that are a bit less than desirable? So APE has this whole thing in it where it wants to implement select, which I totally understand. But in order to do that, the kernel doesn't give you that amount of granularity for implementing something like this. So what you have to do is APE has to intercept these file descriptors. So you call open or read or write, and it's call open to read and write. You call actually an APE function that opens up the actual file descriptor under the hood, and then it does a bunch of shuffling around to have buffers and all these things.
I did find the original quote from Rob, APE can go jump in a lake from 2004.
Fantastic. And the part of this parallel C to the main C library stuff makes code reuse a lot more annoying. You have to, as you write something in the main libc or fix a bug there, sometimes you have to fix a bug in APE. They're two kind of disjoint ecosystems in a lot of ways. Also, parallel makes it easy for things to bit rot. A lot of the APE code that isn't being used actively by programs as part of the standard distribution doesn't get exercised much. Things change out from under it at the kernel layer. It's not tested. It becomes broken. So it kind of in a lot of ways, it almost effectively doubles the surface area for what we have to test for our C libraries.
And kind of this reuse code, so this is a bit, if you were to take libdraw and pull that into ape, well, now libdraw's read and write calls are not actually read and write, they're ape's read and write calls. So now, if you want to run code on both of them, you have to deal with okay, how much is being buffered? Do I need to flush? Like you have to effectively, grapple with the fact that you're now in a quote unquote POSIX environment. It's a bit annoying. It has really reduced the amount of usability that we have in making use of code like this. And of course, being disjoint, not having access to Plan 9 libraries is terrible. I want to use libthread. I want to use our regular expressions library. These are useful things that are useful to use. And we just don't have them in ape because it's hard to fit them in, to bolt them onto the side. And also, for a lot of what programs that we were interested in, POSIX is not really the full picture. No graphics, no audio. There's a lot of stuff that Plan 9 provides that we want programs to make use of that POSIX simply doesn't have a definition for. It's part of that is its age. Part of it is just not wanting to, kind of stick within its niche of where it's good or where it applies. But for us, that's kind of a bit limiting. So I really want to take a step back and think about, really what is portability? How has this term shifted over time? Beforehand, when POSIX was being defined, the idea would be that every system that was a POSIX system would have a similar interface. You wouldn't have specific code for, again, practice is different than ideals, but ideally you wouldn't have like Solaris specific code or BSD specific code. It would just be POSIX. That we all know that that's not exactly how it turned out, but that was the idea. Nowadays, if you go to GitHub and you find some random software project and someone describes it as being portable, what they usually mean is that it was tested on maybe Mac OS, Windows, and Linux, if you're lucky. Works on Ubuntu, ships on Ubuntu, and works on my Mac OS laptop. So and a lot of ways how people accomplish that is specifically in using these libraries that kind of paper over these differences. So you have stuff like SDL2 or Port Audio. They have implementations for Mac OS, Android, Windows, whatever, and you get a familiar interface on which you build your assumptions, and then they take care of all the kind of nasty OS specific bits. So a lot of times, if someone wrote something that just used SDL and that was their only assumption about the world, that's fairly portable code as far as I'm concerned in the current modern audio or software landscape. Kind of talking a bit more about that, like Go, how Go does OS specific abstractions. You just write your code and you put underscore and then the target system and it compiles in. So file underscore Unix, file underscore Windows. On Windows it includes the Windows code. On Unix it includes the Unix code. You just write little interfaces there, you implement them on both platforms, and then the generic code just uses the interface. This is a lot of what I see happening with specific systems these days. This is a lot of how this works. In a lot of ways, kind of portability means to generalize your assumptions. So, if all you want is I want to have a file and read its contents, you can do that on every operating system. There's no hard parts to that. If you want to do weird NTFS file handler stuff, that's not portable. You're not gonna be able to do that on Linux. So the more you kind of remove the specifics of assumptions about what you make against code, then the better you're off. In some experience too, POSIX has these very fine-grained standard rules, and a lot of times people read that oh, there's this really interesting behavior about fseek or whatever, and so I'm just gonna assume that that's the case everywhere. Well, now you're hard tied to specifically, when I mean file, I mean POSIX file, not necessarily just files in general. And most importantly to what I care about is Ape can't run games. We can't, this interface is not well enough to run video games, which is the real core, the real hero of this talk here. So we talk about, a lot of this work goes into Ape for this select stuff, but if you grep our tree, nothing uses it. I'm not aware of, maybe there's some stuff in ports that use the select stuff at one point for some GLIT or GNU ported software, but we don't use it at all. So all of this code that we have here that's kind of working around this limitation, and we don't have any use for it. We haven't used it. Currently only in the 9-front tree, Ape is only used for typesetting, Ghostscript, so PDF rendering, and our audio libraries, FLAC MP3 deck, OGG deck, all of these. This is really the only big use of Ape. Part of that has been due to 9front solely replacing these old ancient like ape diff, ape patch with native versions of these utilities slowly and surely over time. And that's been part of the reason why this list has come so small. But none of this, typesetting, GoScript, audio libraries, none of this uses select. And most of the typesetting stuff like troff and EQN and grep, they don't really need to be ape programs. There's nothing particularly about them that need to be ape programs. I'm guessing someone just didn't feel like digging into the troff code, and I don't blame them for getting that ported to kind of quote unquote native 9front. So how do we kind of address these problems? Well, Sigurd started this excellent project, NOPE, that's how you pronounce it, NPE, which is the absolute minimum amount of code in order to get stuff compiling and working. No like formal environment, just like, okay, you want open, here's open. We if-def, or we define some open flags and off you go. You know, O_read is O read and you're done. It sits on top of our existing C libraries. We don't hide anything. When you call anything from that in a NOPE ported program, you just include it. You want to use libdraw, you got it. You want to use libthread, you got it. No constraints there. And perhaps most interestingly is it has an implementation of SDL2 and pthreads, because we were able to kind of make use of existing libraries. SDL2 is built off of libdraw, pthreads is built off of libthread. You know, when we have access to these things, it's really kind of surprising how little we need to kind of make these interfaces work. Typically also, you know, these days, we try to keep an eye towards how things kind of work on Linux. Not necessarily a hard rule, but a lot of the projects that we're using, they're tested specifically against Linux, so kind of naturally the interface ends up being more Linux-like in terms of, you know, how a function works specifically. I have this mess here where I just want to see, we'll check to see exactly what the line count difference is. So let's check ape first. So right now, the ape library is about 31K. Not cheap, not terrible, but definitely a hefty amount of code. If we compare that against what NPE is right now, we're looking at, you know, a third of that. So this is doing a lot more than what ape is. You know, this is graphical libraries and threading and a bunch of this stuff. So a lot of it is, you know, by being a bit less formal, being a bit more direct, and just doing what the code needs to be done, then we oftentimes can eliminate a lot of this code. And some of it too is like a lot of ape code is just taken directly out of old Unix code, and so it has, you know, it is old Unix code, so that's part of it too. But I feel like this is a pretty good place to start from. And yeah, like I mentioned, an NP NOPE does a lot more. What did we port with NOPE? Well, Sigurd started working with this for UXN, which is a really cool project. Recommend taking a look at it in your own time as a kind of personal computing stack. You write little applications for UXN and they boot up in all of these different environments. Very fun project. Also, DOS era music trackers, Fast Tracker 2, Pro Tracker 2, those are all ported using NOPE, and I worked on some DOS-era computer games, Hexen, Heretic, Rise of the Triad, Wipeout, Duke Nukem 3D, all work as part of NOPE. Cave Story is another project, more of a modern game. I think it was released in the early 2000s, and I want to talk a little bit more about that Cave Story port. It's quite interesting, and just small utilities here and there. So small little programs, you know, like I think I ported a Game Boy compiler and like random little utilities. They don't have much requirements. You can just port them with NOPE. They're pretty straightforward. And you know, every little project we do, you know, NOPE grows a little bit more and a little bit more and a little bit more to encompass a lot of these things. And thankfully, so far, one of the concerns I had was, you know, are we going to come to a point where two programs have differing ideas of what this interface is? And thankfully, we haven't gotten to that point yet. So that's a nice place to be. So why do we want alien software? Our code in Plan 9 is largely homogeneous. Some would say it's too sane. We don't use bit fields. We don't have like a bunch of crazy stuff that we use. A lot of our code is very easy to digest. And more complicated programs really start to push the barrier of what our compilers and linkers and our system does. How does the system cope with 50 processes running in a program, or how do we deal with these absolutely ginormous binaries like NetSurf? It starts to pose a challenge to, not pose challenges, but starts to push the barrier of what things have been tested before. And in the work on porting all these things to NOPE, we found a lot of bugs in the compiler and linker, and also kind of other interesting areas as part of the system as well that kind of led us to being able to find these bugs and fix them. So I wanted to some good war stories. It's really interesting stuff that we found. So Heretic, which is a Doom clone. It's Doom medieval setting. That gives you pretty much the gist of it. I had this bug where you would run around in the game and you have a little inventory and you would like cycle through the inventory and you hit a button and it was supposed to activate the item, but the button wasn't activating the item. It turns out that was because somewhere deep in the code, the player action struct was being copied as a whole struct, and that struct was packed. And we had a bug where the compiler was not copying the last bit of the information. It would go up to the word boundary, and the last couple bytes would just fall off. And so that was easy to find. Well, not easy to find. It was interesting to find. And once we implemented that, and we had a proper struct copying for these pack structs, well, there we go. Well, why don't we find this up? Well, our code doesn't use pack structs. We don't use stuff like that. We do things the right way, but other people do, and it's good to if we have this interface, it's good to actually make sure it works. Hexen had this really interesting code where, if anyone's familiar how RNG works in Doom, you have a fixed table, and you call RNG and it increments through this table with global integers. So a really interesting story is if you have like some func, and you call rands, what is the ordering? If each of those rands have global side effects, how do those get called, in which order? Yes, and we do it how you would expect us to do it. You read it left to right. We call them left to right. GNU does the opposite. They go right to left. So this resulted in really bizarre changes, because if your RNG's off, now all your demos don't work. Everything's a mess. So this is something that's still kind of a problem that we try to figure out. But stuff like this kind of, we don't do stuff like this. This stuff doesn't come up. It's good to kind of at least know these limitations and ideally fix them. Cave Story was a lot of fun to port. It was the first time that a lot of these games on the system, they render to a frame buffer and then we upload the entire frame buffer at once to DevDraw. Cave Story being a little 2D platformer type game, we actually was able to implement a lot of the blitting using just DevDraw. Upload individual sprites as images to DevDraw, blit them onto the screen in the background, and a lot of this was leaned heavily on this, which meant that we had some really interesting properties. Cave Story runs fantastically over draw term because everything is being offloaded just as RPC messages to the other side. I played through the entire game in 1080p over draw term to my main desktop. So that's been kind of interesting. We've kind of had some performance issues with alpha blending. There's a part of the game where you're all underwater fighting a boss, and the alpha blending of the water on top of the characters just completely tanked the frame rate, a bit of an issue. But we found this really interesting bug with unsigned integers for indexing arrays that no one had tried to do before. Apparently none of our code is really using unsigned integers to index into arrays, and that there's ended up being a bug there that we found through some of this as well. Part of the stuff that I've used Note for was Pokemon Crystal has a decompilation project that you can compile, but the original game used this kind of homegrown compression. And so there's some C code that we use to do this compression, and it's just, the guy just loved bit fields, like his favorite thing. Bit fields all over the place. And it mostly works, but we end up with a different hash. And so what went wrong, who knows? KenCC doesn't complain, so that means there's some bug in KenCC about, with respect to bit fields that is yet to be found. So there's, again, when you push the boundaries of what we offer but don't test, you find a lot of these things. Wipeout, the N64 game, and I believe also PS1 or PS2. Also, we had this problem forever. We didn't know, you get into the game and the wireframes, one of the vertices would be infinity. We didn't know why. Well, it turned out to be the short truncation issue that was just kind of sitting around around there for a while. So we find tons of this stuff just sitting around that are never pushed to their limit. So we never kind of figure out what's going on. So lots of fun things to discover as part of that. But yeah, that's all I kind of had to immediately talk about. If anyone has any questions or comments or stuff, yeah.
Just a comment. One of the reasons that ape was adapted from the earlier package, what Andrew was done is that's because he did it to improve the portability of applications within Unix realm.
Oh, okay.
It wasn't originally used.
Okay.
It was to deal with portability problems that were already arising in Unix systems. Different Unix systems.
Interesting.
You get one from Sun, you get some
Yeah.
being different. I had a quick look. I can't find the paper in which he describes it and why he produced it. But that's one reason it's focused, because it's only dealing with the problems of 1980s, maybe.
Yeah.
Or early 1990s. I can't remember. And so it doesn't have to deal with a lot of this other stuff because they weren't using it in the program. The program's there to port. And the idea is you write the program and you write it against that particular interface, and then you could move it to any Unix system within the labs and wider.
Interesting.
And export it to people and be sure that they could compile and run it, sort of thing.
The paper is on the system, even on Ninefront you can see CSDoc ape PDF.
No, I think that's describing ape within Plan 9.
Yes.
And I meant that there's a paper that Hume did describing why he had ape at all, where it came from, and its use in portability inside that. So I'll see if I can find it.
Okay.
Yeah, there we go.
This is also over draw term, right?
This is over draw term, yeah. Yeah, it works mostly fine. I primarily develop over draw term, so this is kind of how I tested this stuff. Mostly works pretty well. I played through the whole game like this without too much issue. Yeah, it's cool stuff, I think. Any other questions? Yeah.
What's your experience been with newer C compiler features that?
Yes, yeah, that has been. I haven't talked about it as part of this talk, but that was something that we've kind of slowly we've picked and pulled little bits of the newer C compiler features that we found interesting. Ninefront recently added no return as a function decorator that we have now. We found use in that. Corey, do you remember some of the other ones we've done more recently?
It turns out that most programs are still sticking to C99.
Yeah, that's kind of what it was asking. How common?
We added pragma once to the C preprocessor.
The funk and line and so on.
Yeah.
Yeah. At some point I'll get around to the one big or two of the big missing ones. So there's missing instruct literals are missing the dot x equals, which is an annoying one to fix, but it's not. And that's the one that I think I run into the most. And then the other one is that we can't do static initialization. There are a bunch of C23 features that I would like to port over. When I get to it, I'll do it. And then run check plateau.
Duke 3D is a bit more rough over draw term, but it does work.
Are you at all worried about the availability of games destroying the productivity of Plan 9 developers?
Yeah, well, thankfully, compilation in Ninefront doesn't take too long, so there's not much of an interest to start pulling towards games. But I have noticed it has impacted my productivity slightly to have these games available.
I will have you know that Go compilation can still take something like 10 minutes.
Okay, yeah, so there you go. Maybe while you're playing that, you open up play a couple of rounds of Duke 3D.
Your CPU can handle it at the same.
Yes.
What's the future of it?
Yes. So there's been this good discussion about kind of what the kind of where Nope and Ape kind of coexist. Do we ship both of them in the system? Kind of what's that about? Well, I think, as far as I know, I want to try taking Nope and porting all of the existing code we use Ape for in 9 front. So the audio decoders, GoScript, and the other miscellaneous stuff that we have. And once at that point, maybe we can switch that stuff over, but still kind of, I don't think Ape's going to go anywhere. I think people still want to use NetSurf. NetSurf's probably going to be on Ape for the foreseeable future. So that's what's next, in my opinion. But there's kind of more work to be done there to kind of get to that point. So.
I can relay another question from Skip on YouTube regarding the order of variation of the function parameters not being specified. That is just for C?
Yes, it's for C.
Right. Okay.
Yes, as far as I could tell, that is implementation defines. That was undefined behavior in Hexen that they did, and it's really funny. The bit of this Hexen and heretic stuff was written by these people got the Doom engine from John Carmack down the road, and they started hacking on it for heretic and Hexen, and they introduced all this undefined behavior that wasn't in the Doom engine before. This stuff happens.
There is talk in the next C standard for actually standardizing the order of validation.
That would be nice. We can do the standard.
My vote's on that one.
Yeah, that'd be good to add.
So I guess taking a less formal approach with Nope, I wonder if we're losing properties that I guess we probably haven't used ever, but in theory, if we fix a bug in GoScript that's using Ape, then that should also be able to be upstreamed onto Unix version of GoScript, for example.
Sure. Yeah, there's.
So that's something that we would use. Nope is for unidirectional porting.
Yes. Yeah, that is a lot of times. A lot of more active upstream. These silly unsynced demos. Hold on. Yes. Yes. So a lot of the benefit is that when you do a port with something like this, then you don't wind up with a fork. You wind up with being able to mostly use the code as is. Usually, stuff like NetSurf still shows that even with that being the case, sometimes you end up needing to change the source code a little bit in order to make things work. So that is a benefit of it. That's definitely why some of the stuff we've looked at tends to kind of like that idea. Like UXN is one where we don't have any Plan 9 code specific upstream as far as I know. So a lot of it is just, well, if it works there, then we can use Nope for it. So hope that answers your question. Yeah. Any other questions?
What sort of documentation?
For documentation for for using it, yeah, it's currently on Sigrid's source HUD account, and it has all that you really need to do is have. Let me go here. So see. You run make install, and then you set the C flags up for this, and that's usually what you need to do. And then you'll find if stuff isn't documented. We don't have specific manual pages for the functions.
I wasn't sure what that would look like because it's aiming at replicating the whatever interface you're mimicking, and their pages should probably be the primary source, I suppose.
Yeah, and a lot of the SDL website ends up becoming pretty useful for this. Okay, any other, yep.
Are there any kinds of functionality that you've run into that's missing in NP that is present in actual porting programs that you want?
Sorry, could you repeat that?
When you're importing actual programs you want to use, as opposed to theoretical things,
What are the biggest categories of missing things in there?
It's a good question. A lot of times when porting stuff, it's just kind of the, I haven't come in anything like large. A lot of times they'll use some library that hasn't been ported. That's kind of more of a challenge. But a lot of what we've been working on is specific like little SDL projects. There hasn't been like wide ranges of stuff. Well, to mention the Chocolate Doom port, I need to implement SDLnet. That hasn't been implemented yet. So networking is something in general that we haven't touched upon with Nope. So, yeah.
Can you just write SDL2 and use this, and it should work for the drawing functions?
Yeah, that's the idea. You write code. I know Quix, he's working on software that he's dual testing. He's writing it for Unix using SDL2, and then also making it work on 9front targeting the same libraries. So that is the idea. If there's divergences there, we should probably figure out what's going on there because it's probably a bug. That is generally the idea. Yeah.
With SDL ported, how long until the rest of the Steam runtime?
I think the Steam runtime uses an entire Ubuntu, so probably not. Yeah.
So at what point though do you fall over and just think I'll run it in a VM?
Yeah, that's something to think about as well. I think a lot of stuff is if it's written in C and not too big, I think that's something that's worth taking a look at for running this. I think VM like stuff, anything written in C++ or like anything written in some other language, anything not in C, you're probably better off doing it in a VM with comparable setup for that. And there's a lot more to kind of uncover about how to better integrate VMX with the stuff, but. A lot of the stuff, with C, it's nice to have, I think. And a lot of times, too, with even like Cave Story is technically C++, but it's basically C plus std string. So it was easy to like just undo that. And then it was C code. So, yeah. All right. Seems to be it. Thank you, everyone.
All right, while we're in the process of switching,
Is this live right now or no?
All right.
Okay, hello everyone. Right now I'm just giving a little presentation over here on industrial automation and distributed control on Plan 9, and I started out by working with the Modbus protocol. I guess I start off as, what is industrial automation? And industrial automation, of course, is automating an industrial process that was originally carried out manually. First it started out with mechanical things, gears, levers, pulleys, cams, and so on. And then over time, as we moved into the electrified age, we went into electromechanical. And you had things like relays and motors and solenoids controlling things. And of course, then computer control came along. And right on the screen here is one of the first industrial control computers, the Motorcon 084. It was originally envisioned by Dick Morley at Motorcon. And his original vision for a computer, because in those times, if you said the word computer, it drudged up these images of rooms full of cabinets and needing to hire expensive engineers in order to operate them. So Morley wanted to kind of figure out a way of building a simpler computer, and he came up with one. And the idea was that there was no interrupts for processing. I/O was directly mapped into memory. And it was a rugged design that was designed to go into a cabinet instead of, it was actually designed to go into a machine and operate on a shop floor where there's going to be dust and dirt and grease and oil. And so, of course, another thing was that it was important that plant technicians and other personnel were able to go in and modify these programs that ran on these computers. And one of the initial languages that were developed for this purpose was ladder logic. And ladder logic is a graphical language that, come on, eventually I'll be able to get it on the screen, which sort of looks like this. And it's pretty primitive in the sense that it represents a ladder schematic diagram that was used in industrial control for electromechanical, where you would have a vertical left and right, which represented sort of like your positive and negative of your control power. And then, of course, you would have power coming in on the left, and then you would have a set of contacts. Here we have an OR set. So if A or B is on, then output Y would be true. And of course, you would have, this is a rung, and you can have many contacts as you want. There could be comparison contacts, which could look at variables and so on. And from there, this enabled plant operators and simple technicians to be able to go into a computer that was controlling machine and actually make and edit changes. And they didn't have to know about all these other complicated processes that, you know, were associated with computers and that were scary. And one more thing of interesting note was that Morley actually said to everybody during marketing of the Motorcon machine that it is never to be called a computer. Do not mention the word computer, and if there was, he would erase it from the blackboard or crumple up the paper and throw it away. It was not to be called a computer. So I guess this, over the years, kind of created a divergence in thinking about how computing works, and it went in the direction of the discrete PLC. And a more modern discrete PLC would be something like this, which is a Siemens Dynamic, or this is a Somatic, I'm sorry. And this is actually inside of a machine at my work here. And as you can see, the processor is on the left, and then you have these I/O expansion modules, analog inputs, digital outputs, and so on. And these are all connected to sensors and switches on the glove box that monitor pressure, doors open, and control pressure solenoids that let gas into the box. And this computer now that sits inside is connected to an HMI. And if I could just get that popped up, which is the human machine interface, which is the other half of it. And sorry about this presentation being very janky. But, well, yeah, no PC present. That was actually part of a troubleshooting operation. But this is what you pretty much would look at. You would just have a very simple interface with buttons and a little readout, and it would just give you a few very fixed functions. And of course, this is very static, and of reprogramming these kind of older PLCs were not very friendly. They were very fixed in terms of function and so on. And on top of that too, I/O is sort of also kept local to it. And then from there, we went into a more modern form of the PLC that we now call the PAC, or Programmable Automation Controller. And a Programmable Automation Controller, let's try and get this over here, looks something like this. So that's a Beckhoff controller, and what that little thing is actually a PC. And it mounts to industry standard DIN rail, which is that little metal railing in behind it. And it has all these little modules that you can add and slide in and out that, again, are your analog inputs, outputs, communications modules, and so on. And of course, since it's a standard PC, well, it boots and runs 9-front. And sort of testing this out. I don't have this fully working yet. There's still a lot of work to be done. But it works out of the box, and that is pretty much the foundation right there of what is industrial automation and these programmable logic controllers. And now, from there, there are various protocols that are used to communicate in between all these different types of devices. For example, the protocol that's used on these little couplers here, these terminals, I should say, is called EtherCAT. And EtherCAT is something that is much more complicated than Modbus. It's something eventually I'd like to tackle. But essentially, it's just structures over the wire, and they're read in real time as the telegram or the Ethernet frame actually arrives through each terminal. There's a little processing chip in there that actually looks through the packet as it's coming through in real time. And then if it's addressed to it, it actually starts poking bits into the empty little containers that you have in the frame, which are just data structures. And this can be done deterministically, and then you can actually create real-time control systems that have cycle times accurate into the microsecond range. And You can do things like real-time motor control, servo control, where you actually close the loop on the controlling computer instead of a dedicated motor drive. So from there, it's why use Plan 9 for this? I mean, you know, if there's existing tools and software out there, why bother, right? And those tools are were historically grew up around the 1990s and around Microsoft Windows. And they use things like OPC, which is the Open Platform Communications, and that was originally based on COM and DCOM. And it was restricted to Microsoft, and it was a big complaint was that nobody could really use it on Unix or Linux at the time, or BSDs, and then so that kind of evolved into OPC UA, and that now is a cross-platform data exchange protocol that allows you to move data between controllers, computers, and so on. Let's see here. And again, using Plan 9 has a lot of advantages because a lot of these Microsoft things are big, really big. Unfortunately, I had a picture here, but Beckhoff, the maker of this controller, uses the Microsoft Visual Studio shell. And so it's a 6 gigabyte package to write code to flip a few bits. And if you think about that little ladder logic diagram I had there before, imagine downloading 6 gigabytes to write that program. So, and of course, right in the middle of it, it'll up and crash on you, or you're running it on Windows 10 or 11 today, and you come back in the morning and you found out that your computer is restarted and Visual Studio or whatever it was wasn't aware of this and didn't save your work that you may have left open or something. And of course, that's on me, but still these things, big software, big problems, you know? And so you also have the problem too where there may have been components that were stuck that enabled real time, and you cannot install these components as their drivers, they're kernel based, on newer versions of Windows. And you're stuck with Windows 2000, Windows XP on controllers, and then you're going on eBay and buying, 20-year-old Dell computers just so you could reinstall this stuff and keep it going. And after a while, this becomes more and more difficult, and it's kind of a huge treadmill that I just don't want to be on anymore. And so Plan 9 kind of eliminates all of that, these problems, because at this point, the OS is the runtime. I don't need a gigantic layer of software or middleware on top of an existing Microsoft or Linux installation. A lot of them are based on co-kernels to provide real time. And it's another operating system running your operating system as a scheduled process. And it preempts your operating system to run the control code. And again, these are kind of obtuse things that are just difficult to work with. They're not user-friendly. You really don't know how any of it works. And when it blows up wonderfully and spectacularly, and then you're just probably usually just reinstalling from scratch. But with Plan 9, you have the entire thing, you have the OS. It gives you a distributed design. I could do things like one disk can boot multiple computers. Everything could be stored, all your machine configurations can be put into the config directory. NDB can also be utilized to set things up and to configure all the different controllers. And then on top of that, in lieu of all these complicated protocols that exchange data between systems, we could just use 9P. There's no need to duplicate things such as copying just small amounts of data, whereas you could just have files representing variables. You could have files representing entire chunks of memory, perhaps. And on top of that, it gives you the ability to just use read and write to get to the data. You don't need drivers. You don't need a whole protocol stack. You don't need to worry about if your programming language has a library for said protocol. As long as your language can call open and call read and write, you have access to the data. And on top of this, too, security is built in. I don't need to worry about using some sort of weird back-off ADS routes thing where you're just adding in weird IP address stuff and all kinds of other just duplicated effort and security mechanisms that are, so they secure, who knows. And instead, now you have per process isolation. You can change the file system view right there for each and everything that you're running. You have file permissions built in, so now you can control access to the data just through the file permissions. And on top of that, Plan 9's really small. It's small enough for a single person or a small team of people to actually work with. And I'm sure there are many people in this room who are far more advanced than I am that have their own forks maintained. Now that's something that you really can't do with just Linux or all these other systems. So that fact right there, that it's small enough, it's easy to troubleshoot, it's easy to develop on, and it's easy to navigate. And on top of that, it's very portable. We don't care that we are on MIPS. We don't care if it's RISC-V. We don't care if it's x86. You just change the object type, and then you build your software. As long as we have support for it, we can run it. And that makes porting things, Plan 9 to different types of controllers that might even be existing, much easier. And once you have the kernel ported, that's it, everything else follows it. And on top of that too, since it's very small and lightweight, it runs on all kinds of hardware. I don't have to worry about if it's, it could run on, for example, I have it running on a 400 megahertz national geode with 128 meg of RAM. I mean, and that's out of the box. That's without tweaking anything. That's without building a smaller kernel or adjusting memory or anything like that. Out of the box, it just runs on these small machines. So it's easy to make work. It's easy to make it work on these different platforms. So where to start with all of this, for me at least, was to get to where I want to be in the future, where I can just use 9front or Plan 9 in general to actually run code, is starting out with Modbus. And what's Modbus? It's a field bus protocol. And a field bus protocol is used to transfer data between all these little terminals and the PLC processor itself. And Modbus is one of the first ones. It was developed by Modicon. It's a very simple, it transfers registers or bits. And registers are 16 bits. Originally, the old Modicon machine was a big endian word machine. And so you just quite literally had a 64K word space, and you would just copy registers or memory values from one machine to another. And those can be, this would also include bits as well, which are used to represent coils or relay coils, so to speak, and contacts, and as well as just individual discrete inputs, digital inputs and outputs and so on. So it was turn light bulb on, you would turn a bit on. And so Modbus has a few basic function codes built in that provide this functionality. There are a few function codes for reading and writing registers and reading and writing bits. So I started out with just this very simple protocol. It's very easy. The frame of it, looks like I don't have the picture of the frame. But, do I? No, I don't. Darn, sorry. But it's a very simple protocol in which it just starts out with 1 byte that identifies the function code. Then there's usually 2 bytes for parameters, usually like a starting address. For example, for reading registers, you would use function code 3. So your PDU, the actual little process data unit, the little frame you would send would just start with a byte that says 3, and then you would then send a word for your starting address, another word for how many registers you want to read, and then you would send that to the server. And the server will process the request and sit there and say if the starting address and the number of registers is correct or incorrect, and if you're good to go, it'll return that data to you. And so since it's very similar to a read and a write, I can map that to 9P very easily. And so one way I just wound up doing that, fortunately let me see. And I wound up doing that by kind of just saying that when I just generated a file and attached a handler to that file that when you send a read to that file, it then calls function code 3. And the file offset, the seek number, the seek offset is then used to determine where you're going to start in the registers. But of course, you have to map bytes to words. And it's not that hard. You just multiply by 2 or divide by 2. And just with a little bit of math, we're able to translate a byte read call through a file and then map it to a function code to get the data out of the PLC and then return it as a stream of bytes. And I did that using a very simple little Modbus library I came up with. It only concerns itself with serializing a function code into a frame and then sending it out to the server. Server says yes or no, and then returns your data or an error. And I never bothered to put any kind of data handling in the library. It just returns bytes. So the user's responsible for dealing with that. Are they words? Are they bits? The bits actually are packed into bytes when they come in. So it was easy there. But yeah, and then opposite way of doing this, would I serve data from a Plan 9 machine to a PLC, for example. And that was the idea I had for a Modbus daemon, and that serves a file using Modbus. So I have a very small little listener that listens for Modbus frames, and as they come in, they're processed, and what I wound up doing was mapping out the file to where you would say where your registers live, where your bits live, if they overlap or not. And from there, return the data from that file as if you're looking at PLC registers or bits inside of it. And that was able to kind of make things a lot easier where you can now share both ways. So you can either read data out of a PLC, or you can serve data to a PLC or even an HMI, which is the human machine interface, or the little user interface. Let's see here. So I have, a few little working code. I don't have anything here, unfortunately, anything exciting. It's kind of at home. But that's where I'm starting at with all of this stuff. And I eventually would like to get to the point where I have a machine actually running some of this code. And I kind of have started a little bit at work. Unfortunately, this kind of machine, this is actually, you can see there, I have a little tiny little PC down there, and that's hooked up to an existing PLC, and there's just some test code up there. But this is actually the inside of an electron beam welder, and this we actually are installing, and we move this machine, and it's quite a project to put one of these things back together, as there are 1 million wires inside of them. And of course, this is also an electromechanical machine originally, and we're sort of now adding computer control into it as well. And this is like the ideal area where, well, this is what originally you looked at, tons of relays. And it's nice that you could replace all of that with just something that is as tiny as this little guy right here. And it also eliminates enormous amounts of wiring. Let's see here. There's an old panel here. Yeah, so here's the inside of an old panel. So this spaghetti right over here is what somebody would interact with. On the other side is all knobs and levers. It's all knobs and dials. The other side of it actually looks like this.
What's that device again?
It's an electron beam welder.
Okay, we're still on that.
And this machine right here, this particular panel and everything, this is state-of-the-art late 1960s, early 1970s. The person operating this machine pretty much had to know how to how to operate every single thing. So for example, an electron beam welder, it actually fires a beam of electrons inside of a vacuum. So the part has to be inside of a chamber, and that's what that is. A little window back there looks into the chamber, and the operator sits in front of it, and they look into like a little periscope thing. And so now, right over here, you would actually have to manually cycle through your vacuum. So somebody would have to sit there and look at the vacuum gauge and know when the appropriate time is and know the pressures. So the person had to automate the process, and they had to be educated about the process. So an operator not only just had to know how to weld, they had to know how the entire machine worked. And so this very manual process where you would have your motor control for moving the table around, you would have your vacuum, then you would set your beam current parameters and your high voltage power supply, and then you would even have a little beam deflection over here, which can actually, it's like a giant CRT at that point. This is actually a 7.5 kilowatt CRT. And then there's another one that we have 15, but this one right here, you would just be able to move the shapes around and the deflection around in just a circle or a straight line. And we took one and went from something that looked very similar to that. Let's see here. There we are. So you go from something like this, where it's a big giant manual panel, and this is what modern automation would give you. This is another machine. This is the 15 kilowatt machine. So now what we actually have is we have an HMI all the way off to the left that deals specifically with the vacuum system. And now the vacuum system are those two colored buttons in the upper left-hand corner. Blue meaning that you're under vacuum, and yellow would be that you're vented. And so that right there, those two buttons, which just operate some code inside the PLC, completely remove the entire need for the operator to just stand there and stare at the machine and index a knob. And of course the boss loved that because now they can actually do more work while waiting for the vacuum. So, and then of course the process is then automated through here with the motor control, and this is actually then created two fake axes, and then we wired that into the deflection amplifier, so now we can actually move the beam around via CNC as well, in addition to the table. So all of this automation right here moved a machine from basically the 1970s into the 2010s at least. And the guy who was able to sit at this machine doesn't need to know anything other than I put the part in, I push the button. And further from that, there's even more automation that you can provide that even does things like joint scanning and tracking. This machine doesn't have it, we have one that does. And that you can literally just take anybody and it becomes a real George Jetson machine where all you just do is one button continuously. And it does everything for you, including venting and pumping down the machine. So these levels of automation here can just be done inside of a computer. And we don't need all this huge amounts of complication. Right there, there's Windows running. That little guy on the left there that little HMI on the left has to be programmed through a USB cable, through another piece of Windows software. Windows 10, basically the vendor sat there and told us that that's for the CNC control. They said, do not, under any circumstances, plug the Windows PC into the internet. Updates will immediately murder the software. So this is the kind of stuff that would drive me mad, and I have piles of Dells and even computers to run DOS and DOS HMIs. And so a lot of this stuff at the end of the day is just flipping bits, just reading and writing stuff. Industrial automation isn't complicated. A cave story has more code in it probably than this whole machine does. So at that point, you don't need these huge contraptions. I want something small and simple. And Plan 9 really gives that to me. And I can have things like my PLCs, and I can have multiple in one cabinet, and I can boot them from one disk, and I can configure them all from NDB or the config directory. and write very small, simple code and serve all these resources such as field buses and all these I/O points and everything just as files. And I could bind them all into a namespace specifically for a certain PLC control program, or I could distribute them and I can have different small little PLC processors all around the machine handling different tasks, and then they just supply maybe small little files out of them. And that's in the future for what I would like to do, is have maybe even a little PLC runtime where you could look inside of it and you could register variables in a little 9P sort of server. And then, you know, your things like vacuum pressure can just be a file. And then it would just pop up right there and you could open that up and then you can read it. And if you have the right permissions, perhaps you could even write it. So you could change settings too. Another interesting thing that I thought of about that is that it would kind of allow you then to just sort of back up the PLC with things like tar or zip, where you can just go through a whole directory and just grab an entire snapshot of everything and then write that into an archive, and then there's your configuration, or there's your snapshot for that particular point in the program's execution. So yeah, this is what I've been doing and poking at little by little. Unfortunately, progress is a little bit slow, but in the future, you know, I want to be able to get this to work on actual machines, get it to where it's stable enough, where I can just actually use Modbus to communicate with some of this stuff and get a PLC program running, start working on the other components for it. Such as maybe even like a little HMI library, some kind of graphical thing where meters or sliders or knobs and buttons and dials, and some kind of little PLC runtime, and just have a small little thing, and then from there build up with more protocols, possibly interacting with higher level stuff like MQTT, OPC UA, which is the newer version of OPC, which thankfully does not use COM or DCOM anymore. But still, you know, when you look at these things, they're still huge. And I think I remember looking at the boilerplate to instantiate a variable on OPC UA is something like 20 or 30 lines, you know, the integer speaks German and things like that. So, you know, there's a lot of boilerplate and a lot of verbosity. And I just think it's kind of pointless when you just have 9P. And so that's what I want, and that's where I want to go. So yeah, that's pretty much it. Any questions? Sure.
So I have actually a practical question. This is one of the neat talks we get where somebody in this world is doing this, right? And the thing you always get, I'm sure you get, is, oh, but that's weird, or whatever, right? And,
oh yeah.
Or but you don't get support. So this is where now I'm sitting here thinking, suppose there's a foundation that could somehow help with, because we've never had that before, actually. We've never kind of had this advocacy and support. What thing could such a foundation do to help you make progress at your company? If anything.
I think just getting people who are probably more talented than I at programming, helping me out, giving some assistance, and just taking an interest and just kind of helping, you know, me further the software along to get where I want to get.
And the flip side, if you ever got somewhere with, well, no, I'm saying you've gotten, suppose you get to the point where this is actually ending up in use in a real world product, right? Mm-hmm. Would your company be open to being on the website as like case study, successful case study of actual deployment?
I would have to talk with them, but it is possible. I've thought about it. We're under new management now, and they're very open to new things. So I'm actually, that's a very good point. I have actually played with the idea of actually telling my boss and saying, well, the new president, and saying like, hey, I have these ideas, but I kind of want to don't introduce that yet until we're done with this big project here, because
yeah.
But yeah, and of course, another thing that I hadn't thought of too is also with a lot of these protocols, you have to be a commercial entity in order to access documentation and so on. For example, EtherCAT the EtherCAT organization does not allow individuals to join. You have to be a commercial entity or an academic entity, and then you will Then get access to documents. Some of these things you have to pay for. You have to pay for some of the specs and standards. So like access to those things would probably be something that the foundation could help with. Also certification. Any of these things are safety related. A lot of these protocols offer safety mechanisms to comply with things like functional safety, all the way up to like SIL 3 and 4. Safety integration levels, and SIL 4, for example, would be something that directly handles human beings, a train, a car. So these are very high levels of safety that, well.
That's the scary one.
Yeah, so these are things that require, you to certify. And that would require auditing code, proving, that your code is correct and operational and so on. But it's a big thing, but yeah.
Do you have tools? Are there tools that you refer to for this auditing? It's not human, is it? It's really literally all human, or are there automated systems that you like to have in use for auditing?
I haven't gotten that far yet, so I really couldn't tell you. But yeah.
Do you know if there'd be any upset because it's not a quote-unquote commercial compiler tool chain?
I think, the way I think about this is 2 levels. There's the end user level, like my business there. They wouldn't give 2 shits what it's composed of as long as it works, right? That's the end thing. Like a lot of the times, a lot of people sell you all kinds of janky things inside of a box, and the company just buys it because it works. Yeah. And they don't care what's underneath. But I think that regulatory bodies or any place where they might be concerned there may be some end users that do require, very large facilities would require some sort of standard, at least there's some safety.
I can tell you for a fact, the compilers are not included in the safety.
They're not what?
The compilers are not included in the safety assessment. Because they're using client and GCC.
Oh, I know. No. There's the reality and the perception, right? You know how this goes, right? And so, but yeah, I totally agree.
And now third-party graphics libraries and other stuff.
Yeah.
So those are lightly certified. Like, in other words, a specific graphics library content will be run through some various kinds of analysis. And a lot of testing to say it seems to be okay as far as it goes.
Yeah.
It's a strange business.
Yeah, no question. Yeah. Do you have a question? Oh, no.
No.
Okay. This is really neat.
I just have one question.
Sure.
Do you intend or do you have used the real-time capabilities of the online kernel?
That is exactly something that I want to research out into the future, especially when you're getting into things like EtherCAT, where you use cyclic timing, where you can schedule on a deadline and you can say, for example, every millisecond run this code, and you can, or even faster than that, and guarantee that the process is scheduled at that point, and then you can do things like I was saying before, like servo updates and so on, and motion control to really get there, and it must be predictable. So, yeah, I've definitely thought about it, but I have not gotten to that point yet.
You mentioned MQTT. Have you gotten anywhere with that? I was looking at that last year or something.
Yeah, I haven't used MQTT yet in my own work. I actually have been wanting to, but we don't do, like, MQTT is very useful for things that you have kind of like distributed and scattered about. We don't have a lot of things scattered about the machine. The machines are very small and local, but I'm sure in areas where there would be, for example, monitoring, building monitoring is probably one of a big use of it, where you would have temperature sensors and humidity sensors and so on all throughout the building. But yeah, no, that would definitely be a very useful thing to have, is MQTT for sure. That is kind of today probably, Modbus is actually very primitive, but it's still an open standard, and pretty much everybody supports it out of the box nowadays. So MQTT is sort of kind of displacing that as your sort of standard little protocol to communicate between controllers, process data. So that would definitely be a place to look today, yeah. Haven't looked at it myself yet, the technical port, but eventually, yeah, it's something else. Anybody else? Sure.
How long before you can get Doom to turn off relays?
I really wanted to do that too. I wanted to figure out if there's a way of doing that, if you can just sit there. Yeah, exactly. I mean, that would be like cool as hell, like your HMI is Doom, I mean, somebody remember PS Doom, if anybody remembers that from back in the day?
So how do you map the monsters to relays?
That's something that we have to think about.
You'll let them program in Minecraft.
Sure.
The other real thought, I mean, so the TCP stack was originally outside the kernel, and then got pushed in, and I talked to the guy who did that about it, and essentially it was nowhere near the level of effort that you would think of from the Unix world. So for your real-time stuff, there really is the idea that you can actually develop the thing entirely outside, and then because the sort of set of things that have to be done are so similar in and out, you could seriously talk about saying, oh, we can put something in a kernel and do better than, in a way, you could never do in Windows.
Right.
Because nobody wants to write Windows drivers. They're horrible, right?
Yeah.
So, I mean, there's that other additional argument when you get to hard real time that, well, if we have to, this is a kernel that's actually approachable enough to really modify for our needs.
Right, yeah.
So,
and it's the simplicity that I really appreciate about the whole system. And that's the real important part. Yeah. And I think that would make development a lot easier and faster.
It's really interesting.
Okay. All right, thank you very much, everybody.
So I always need to switch a bit because there is a delay between what we see here and YouTube. Like 15 seconds.
So I'm testing the microphone by talking and not being very interesting.
I will hear the microphone here when I do this. So just keep talking.
Okay, I can keep talking. I will talk like that. Blah blah blah. The weather is nice.
I will mute this.
Just stop training.
Just keep talking.
I keep talking. There is a red pen on the desk.
Okay, just keep
yep.
talking.
Okay, we are about to start. But people are still standing. Yep. Still talking. Still testing. Again and again and again. Bah.
Yep. I'm hearing a lot of background noise.
A lot of what?
But I think it's because everybody is talking.
Yeah.
Okay, I might need to turn this hello everyone, welcome back. Hey, all right, so next up we have Edouard, and he's talking about adapting Plan 9 Listen to GNU Gigs.
Thank you. So first, before I begin, I would like to say that I'm very happy to be here. I've put, I don't know if you know SMBC, it's a webcomic, a daily webcomic, quite funny usually. And this is basically how my wife sees me when I talk to her about you. So I wanted to share this excitement with you. And yeah, it's very nice. I was very happy last year when the conference started again after a 10-year gap. And so it's nice that it's now an annual event, and I'm really hoping that next year we will meet again. So what is this all about? Yeah. Why did I try to adapt Listen to a specific Linux distribution? It's because I'm running a public access Unix server called the DAM, and it's not big. The graph you see is the daily active users on the chat we have, so you can see that I'm not alone, but we are not a crowd. So every one of you is welcome. There used to be a 10-euro fees, but it's no more of a anti-spam measure. So if you want to join, I can give you an account for free, of course. But people from the internet that are listening to me now can also join for free. But random people need to pay so that I can have some data to give to the police if they do something bad. Anyway, the goal of porting Listen was to answer one question. This server has a set of a few 10,000 of ports. And I wanted to share those ports fairly and securely with the users of the system. And it's not possible on Linux because you have a dichotomy. Either you are root and you can bind to anything, or you are not root and you can bind to only the unprivileged port, but anybody can. So the fastest win, which is a kind of a silly way to attribute ports. And so I wanted a system where ports were mapped to files, and then we could use file access control in order to share ports. So what is good? You all know what Listen is about, so I'm going to be fast. But as I said, port as files is a good way to use access control on ports. So somebody can bind to a specific set of ports. You can attribute more very easily with just a chmod. It's quite nice. And Listen has a property that because the files are scripts, and those scripts get the data from the standard input and output data to the standard output, they are what I call network agnostic, which is to say they don't know that they are on the network. So you can use any Unix command line with pipes or whatever, and you can create very easily a network service. So for example, you kind of all know, but anyway, this is what the echo service on 9 front looks like. It's just cat, because what you get on the input you give on the output. And on the other side, you will recognize RC HTTPD, which is a script that actually parses and speaks HTTP, which is to me kind of magic, because when I teach that to students, they find it kind of magic, because the browser is a black box, and the HTTP seems quite complex to beginners. And when you say, no, you can just parse it and speak HTTP basically with a shell script, it's a very good teaching tool, you know. So I'm happy that such tools exist. What does it take for Listen to work? It takes two ingredients that Plan9 has, which is per process namespace and unprivileged mounts. Because if you have, if every process is isolated from the rest of the system, then you need to be able to mount stuff in order to populate this namespace to do anything useful. So let's take a look at how it's done in practice. This is the namespace file for the default web server from 9 front on the right. So you see we bind the web root somewhere, for example. And on the other side, you have the one from the. I guess it's still in 9 front, but given the name of the machines, I guess it's a remnant from Bell Labs. I don't know. Maybe somebody knows where this file comes from?
Yeah, it's just old stuff.
But what's interesting, it's like digital archaeology, you know. You see the name of the machines, and you see how the folders were created by binding one folder over the other and so on. So yes, this is what I show to people who ask me what namespaces are about. So you can basically build your own view of the file system, but you all know that. The problem is when you come to Linux, you can try to make Linux look like Blender, but it doesn't work because you don't. Yeah. When you have a namespace in Linux, you have Linux namespaces. Why is there S? Why is there multiple namespaces? Because everything is not a file, like at all. So you need to isolate mounting and networking and users and even the sound, I guess, or whatever. You can look in man unshare and you will see all the different kinds of resources you can isolate, and it's not clean at all. And you can do unprivileged mounts. You can use the unshare command to enter a so-called namespace, Linux namespace. And M and R, M is for mount, so you can isolate whatever you mount from the rest of the system. If you mount something in a mount namespace, other will not see it. But in order to be able to do that without being root, you need also to pass a map root user, which give you kind of a fake root, and you will be the root of your own CD kingdom where you are learning. So with both of those, you can kind of manage, kind of. When I started, I was like, okay, this is going to be a 1 week affair. I'm going to work 1 hour a day after the kids are in bed, and I'll be done. And this was like in May last year. And why? Because it's actually quite, the problems I encountered impacted the design. So first question, this is attributed to Rob Pike, but I was not able to find an actual source for the quote. The earliest I could find was Uriel, you all know him, telling us that Pike said that in 1991. But
I think that's a Utah.
That's a?
Utah 2000.
Okay.
It's very old.
Nice. Yeah, so it's even more relevant now. And so what I will do is I will first describe the 3 problems I had. Then I will show you the listen design on Linux. And then I will come back to the problems and explain how these problems impacted the design and why I had to make the choices that I made and that make this design subpar and not as good as in Plan9, basically. So let's start with the problems. Problem 1, there is no netfs, no /net. So this is the way /net works on Plan9. You open the TCP clone file, and what you get is not actually an handle on the TCP clone file. It's the handle of some other control file, which you don't know which one yet. You read this file, and you get basically the name, the number of the connection, which you can then use to build the name of the file you actually need to open. But once this file is open, whatever you open, you read and write to this file will be read and written to and from the connection. So this is a clean, very nice design. And it's even cleaner when you look at, so this was, to connect, for example, to example.com, you would do this little dance, which is, of course, abstracted away by some calls that will just do that for you. But when you listen, it's a bit more involved. It begins the same, but then you have to do the little dance again with the new which the FD for each incoming connection. But what is nice is because you are on plan 9, for example, listen will be the program here. And when a new connection comes in, you can actually hide all of the rest of the system from the daemon that is the process that is handling the connection. And the process handling the connection does not see the full /net. It only sees this particular directory. So the process that handles the connection is not internet aware, is not even able to make a new connection. So if your process gets compromised by an attacker, then it cannot use your machine to go forward into your network to other machines because it has no internet connection. This is a beautiful design, and I would like to be able to replicate it on Linux. For problem number 2, it's a bit technical, so I have created a visual aid to help you understand what's actually wrong. So this visual aid will show you what it's like to be inside a Linux mount on user namespace and trying to mount any actually useful file system. So it basically goes like this. It goes like this. So basically what happens is because you could, if you are an attacker, create your own fake disk, and because unprivileged happen, try to mount this fake data, this crafted data, could go through the kernel and allow you to attack a part of the kernel that is not prepared to handle untrusted user data. So because of that, the kernel developers said, okay, unprivileged mounts are good, but only for trivial file systems. So TMPFS, for example, but any useful data file system like X or whatever, FAT even, is forbidden. What you can mount is Fuse. It's basically the only useful file system that you can mount. I do believe that v9fs, so the 9p implementation in kernel, should have made the cut, but from what I gathered from my peering at the Linux kernel mailing list, nobody actually got around to do it, and so it stays undone for now. So you cannot use the v9fs, which is quite good and that I want to use because its performance is good and it accepts all versions of the protocol, but you cannot within a user namespace. So, and the third problem is that privilege in Linux is inherited and inherited only. So if you are inside a namespace, you cannot get privilege by any means. So tricks that you may use outside of a namespace, like for example setuid. I don't know you mount a 9p system on Linux, but I use 9mount, which is a setuid utility that will call mount for me, but as root, and it's quite secure and it's well made. But from a user namespace, it's not going to work. Same for capabilities. So for example, if I want to bind to a port, I can get a capability that will let me do that without being root. But from inside the namespace, it's not going to work. And this is not documented anywhere. I had to email the kernel developers, and they told me, yeah, what you want to do is nice, but it's not possible as of now. So this is a design that I ended up with. Basically, you have your listen process. that will share some file with a container. I will say container to avoid using namespace because namespace is a Plan9 concept. So inside your container, you mount some these paths are specific to gigs. I will explain them later. But basically, you have your for directory where every service exists, and this the runtime directory for the service is mounted as just /run. So if you don't have to know which service you are, for example, you can just go to /run and it will be mounted in the right place. And same for log or whatever. And what basically happens is this script starts, and as soon as it starts, and if it works correctly, it will create this socket. And as soon as listen sees that this socket is created, it will use socket to listen from on the network and plug all the data to the socket. So this is my way of compensating the lack of a /net. I use 2 instances of socket. So now that you've seen the design a bit, let's see how it's why it's that way. So for example, in Plan9, we don't have socket. What is socket? Socket is a small utility that will let you plug any 2 types of input-output. So if you want to talk to a FIFO, but your process will only listen on a port, you can use socket in between to take data from the FIFO to the port and back to the FIFO. Same for Unix domain socket and a remote socket, for example. So you can pipe any kind of standard input, standard output. Anything you want, you can pipe it with socket. It's very nice. Yeah, so listen.c. These 3 lines that I have highlighted, I can maybe be a bit bigger. This is on Plan9. What you do is you remember the data when we did the little dance to get there we get a data file handle. Okay, this is the internet connection. This is a file handle, but when you read and write to this file handle, you will get data to and from the internet. And so there is such this is such a file handle. So what they do is this file, they bind it to devcons. So if the child process, the server process, is trying to access the standard input and standard output via opening devcons, what it's going to get is data from the internet. But the file process is not even going to realize that. And same for the already opened standard input and standard output. They get what they get instead is a duplication of the file handle. So with 3 lines, Plan9 is able to not need socket. But because I don't have a /net, I'm not able to have a file handle that represents the internet connection. So I cannot duplicate it to the standards and standard streams. So what I had to do instead is use socket twice, once to get data from the internet to a socket, and once again from the socket to the standard input, standard output. So this is ugly, but I have no choice. Same, the particular directory under /net for the connection is given as a third argument to the services. Not many services use that, but if you actually print your arguments, you will see that the third argument given to the service is the particular directory where the connection happens. So you can do stuff with the connection. Because there is no /net, there is no such thing on Linux as well. Let me just check. Yeah. Also, because some Plan9 services rely on /net being there, I cannot directly port Plan9 services to my system on Linux because they will just fail because /net doesn't exist. So there is some portability work to do if I want to enjoy all the services that people are deploying on Linux. Okay, in my paper, if you read the actual paper, I've made a bold claim. I've said that without my fuse wrapper, which is called F29P, there was no way to mount 9p2000.l server on inside the Linux container. This is actually true, but it's a bit of an overclaim, and I apologize for that, because I've systematically now tested every Linux 9p server against every Linux 9p client to see if they were compatible between one another. And this is what I found. So this is in with root. So basically, almost everybody can mount a U9FS. And nobody can mount P9 UFS. But P9 UFS is the nicest of all. It's written in Go, it's quite fast, and it's actually quite clean. Sorry? Yeah.
That's the one from Google?
Yeah, the one you told me to use.
I use it all the time.
Yeah, it's very nice.
So why didn't it work for you?
It's unable to negotiate a version with older software. So if you don't tell it you're speaking exactly the good version, just at the version negotiation, it's going to fail. I think this is easily fixable, but as of now, it doesn't work. Yeah, so most of them work, but when you get into a user namespace, remember, if you try to use the in-kernel implementation, you won't be able to because it's forbidden. So you're left with those one, and U9FS needs to run as root because it does some authentication and it's going to want to switch users. So you can fake root by running the server process in a namespace as well, but it's a bit more involved, but it's possible. So that's why you put them in yellow and not in green. So you're left with that, and the problem is 9pfuse is not speaking 9p2000.l, but just 9p2000. So if you have some calls that you want to make, you may run into some incompatibilities. Some system calls may be silently ignored by 9pfuse or whatever. And the same goes from 9pfs because it's not going to use the best version for, I think it's, yeah, diode, for example, can speak 2000.l, but it's not going to do that with 9pfuse, for example. It's going to downgrade the protocol to 9p2000. So if you rely on .l features, it just doesn't work. So the best couple stays P9 UFS and F29P. And we wouldn't need this part if this was allowed inside a user namespace. We would just use all the in-kernel implementation, which is the best of all. Also, because inside the kernel you cannot get capabilities or set UID, I could not put the listening process, listen, inside the container. Let me go back to the design. This should be also in a container because it's connected to the internet, so an attacker can maybe get a hold of this process. And if they do, they have full access, not full access to the system, they are still constrained as the listen user, which is a nobody-like user, but still, they can listen on any port and they can mess with existing servers. If it was in a container, the damage they could do would be much less. So I would have liked to run this process in a container, but I cannot, because if I did, I wouldn't be able to bind to ports, so I wouldn't be able to listen, which was the whole goal. So, and what is infuriating, when I looked at the source, is that the kernel keeps track of in which namespace you are capable, because you can give yourself capabilities inside the namespace. And these capabilities will be true in your namespace, but false outside. So if you have a setcap binary outside of your namespace, and you try to use it inside, the kernel knows that it's actually a capable binary, but just will not let you use that. So I don't know why. I think it's because the design was bolted over afterwards, but yeah, it's not good. Let's see how it goes from the point of view of the user. Basically, so this is echo service, and the user doesn't have to worry about any complicated stuff. Yeah, on this. So if I list my TCP7 script, it's just a link to cat. So this is easy. It's even easier than in mainfront. Let's look now at the finger server. I've created a finger server, but the finger server is only useful if you can access data from the hard drive. Otherwise, you don't have anything to answer. So what I did is I created a container which ran a 9p server. And this container speaks 9p on a socket. This socket appears in the namespace of the listening service, which will mount it. And the actual script can go and see that data. And this is done not like in Plan9 with a namespace file, for a reason that I'm not entirely clear with, a namespace file in Plan9 looks like a script, but is not a script. It's something that you give to the calls newNS and addNS, I guess, but it's not a script. I don't have any of those system calls, so I had to create a script. Yeah, this is what they look like. So it's a script. What they do is they just mount. This is like a bind. They mount the finger folder over to a survey finger, and then they just exec whatever command is given to them. And this is what you saw on the. This is this link. So the namespace script is run before the service, and then the service script gets the data and in a namespace that is built for it. And then I'm very happy, Ori, that you showed your TCP 9418 script, because you showed that it's possible to speak Git on the standard streams. But I'm a bit lazy and I didn't want to do that. So what I did is I abused the namespace script, and in order to leverage a server that would not talk to the standard stream. So if you want to serve the Git protocol and you only have the Git executable, you cannot do that on the standard streams. So if you just run git daemon, what you get is a server that listens on port 9418. So my namespace script for this one, it mounts the directory where Git repository lives, and then it creates a fake network interface, and it runs the Git daemon, but it does not exec the command that is given to it by listen. Instead, it execs sockets. And what socket will do is create this socket, and so we can redirect, instead of redirecting the data from the internet to the input-output of Git daemon, which won't speak any coherent protocol, what we do is we redirect it to the port instead. And so by abusing the namespace script, we are able to use listen even if we don't have a piece of software that uses the standard streams. So this is a way to stay compatible with the whole slew of servers on Unix that does not use the standard streams. So this is a bit of a hack, but it works, and that way you can have any web interface that you want. You are talking about web interface to Git. I can run like Git.r or whatever inside the namespace script, and then redirect data from the socket to the port, and then it's going to work. If you want to try, you can netcat to port 109, and let me show you what's behind port 109. Can you guess what will be behind port 109? It's a link to bash. I am confident in my containerization, so you can run bash commands. Yeah. So have at it. Please do not do a fork bomb, because I do not protect myself against resource exhaustion. But if you can try to access files you should not be able to access, or if you manage somehow to exit the container, I would be very happy to know about it. And I have no money to offer you as a reward, but you have my thanks. So you can play with it. It's live now, and if you want to try, you can. I'll probably stop it after today, but you can try. Yeah, and the software you have available, for example, if you do. You see you're there, but you don't have like a lot of software because you are on the default namespace with the default profile. The listen server needs Python, for example. In order to give Python to the listen server, I had to create a profile. The profile is just a directory in which geeks will put links to the store where it's where all the software is. So, for example, if I do that. Listen TCP 77. Yeah, of course. So, for example, you can see that this profile is a directory with like a bin, a share, whatever, and anything that the software needs is actually links to the store, and the store is a read-only place where geeks only can put executable files. So this is another way of securing the stuff. the server only gets exactly the piece of software they need and nothing else. So this is for my finger server, which is written in Python. But if you try port 109, you will end up with a default profile, which is this one, I guess. And yeah, I can show you what's inside. You get Geeks, of course, you get Bash, you get the core utils, Socat, and you get the utils to get a fake network interface. But that's basically it. So the opportunity to get the specific binary you need in order to do privilege escalation, for example, are very slim. It's not impossible, but still, it's less open than a full-blown Ubuntu system, for example. Yeah, so let me just talk very briefly about Geeks. I think I'm running out of time, but I'm not sure. So Geeks is a Linux distribution. Basically, if I had to do the history of Geeks very quickly, it's some guy in 2012 decided, okay, it sure would be nice if my scientific processes of data analysis were reproducible. So I need reproducible packages. And in the quest for reproducible packages, he understood that he needed to do a whole OS because to actually build bit by bit reproducible packages, you need to know what your dependencies are, what is the environment in which you are building them, and you need to stabilize all of that. And in the end, you are building a full-blown OS. So what is good about Geeks? There is no systemd. This is very good, very you can understand what's going on. You have atomic updates, either it updates or it doesn't. And if the update is not good for you, you can roll back for free because as I showed you, everything is a bunch of links. So you can edit the store, but the store is a content addressed store, so it doesn't erase your previous installation. And if you want to go back, you just have to change a bunch of links, and you can go back very easily. And everything is declarative. And for example, you've all heard about the XDead attack recently. You know what I'm talking about, right? Some guy puts took 2 years to become a maintainer on some compression software, and he introduced some very subtle test data, and this test data was used to create a script that was used to put some bad code into SSHD, which is beautiful when you think about it. So this is not impossible to carry out with Geeks, but it's much harder, and because you have all the dependencies that are listed, and it's very easy to audit them and to freeze them once and for all. So I cannot talk about that because I have only 20 minutes, but if you want to know more, I can talk for hours about this, and it's for the supply chain attack, it's very good. It's very nice. This is what my configuration looks like to install Listen on a Geeks OS. So you see it looks like, I actually need to put it bigger maybe. It looks like an imperative, like a Docker file or some imperative language. So you say, yeah, I want those packages, I want to create this group, I want to create a nobody-like user called Listen. I need to make those directories with those mods and so on. But in fact, it's not an imperative language at all. It's in a dialect of Lisp called scheme. And you see this little operator there. It's a bit of syntax that will take the return value of this function, because this is a function call, and put that as the first argument of the next function. So what you see here are actually nested function calls and not imperative instructions. And this is very nice because you have a full-blown programming language. And for example, something I did is, okay, I have Listen, but I need to share ports between users. So when a new user comes in, I need to allocate a range of ports to this user. And this is some bootkeeping. If I do that in a linear manner, when somebody leaves the server, then I have a hole. I need to defrag my ports on it. So what I did instead is I wrote a bit of scheme, and I just take the hash of the username. This gives me an int, and I use this int as the start of the range. The collision risk is minimal, and a user can come and go, and this is an automatic attribution chain that actually works. And I can do that because the language, the configuration language, is a full-blown programming language. It's not like in Ansible, like a YAML or whatever. It's a real programming language. So this is, you get both. You get like, let me get back to it. You get easy intuitive when what you want to do is easy, but if what you want to do is complicated, you can also do it. So you get both. Anyway, time to wrap up. What am I going to do in the next few months? I would like to edit P9 UFS so that it can negotiate the version better and maybe work with the existing software. Because I think once the version negotiation is done, it can the needed the modifications that are needed are not very big. If anybody here has experiences proposing a patch to the Linux kernel, I would very much like the V9FS to be marked as safe so that we can enjoy it inside containers, because so far it's not possible. So if you can, please talk to me, because I have no experience in that domain. If you want an account on the DIME, I will be very happy to welcome you. And then if you have creative uses for Listen, you will be able to use it and create scripts that will listen on the internet. And also, /net is just so good. So I would like to first fake it, like create a fuse file system that behaves like /net, and so that we can use it and begin to see if it's actually useful on Linux. And if it is, armed with that experience, maybe we can prepare a patch for the Linux kernel and someday have an actual /net. I mean, Linux stole the /pros from Plan9, so maybe we can steal the /net as well. That would be nice.
Yeah, I think there was a project called Blendix trying to do this kind of stuff.
Like try to emulate Plan9 environment on Linux kernel. I'm not sure how far they got before they abandoned it, but yeah, I might try to explore. Maybe it's done.
Okay, yeah, I look into it. I've heard the name already, but I didn't know. I don't know where they went. And last, I would like to thank you all for being so attentive when I talked, and also thanks to the reviewer of the paper, because my code was shittier before, and thanks to the review, I, for example, extracted all the namespace stuff out of the script. So, for example, the cat, the TCP7 service, before the reviews, included the socat invocation, which was not intuitive at all. And thanks to the review, I was able to understand that I should extract it, and I created the namespace scripts and so on. So the reviews were actually helpful, and I've submitted a lot of papers to a lot of conferences in my life, and I can tell you that actually helpful reviews are very rare, so I'm very happy that I got actually helpful reviews, and thank you to the reviewers. And thank you also to the participants of last conference. So Ron is here, and Skip also, I think you are listening. And during the workshop, you provided me with very interesting information that I used in my research afterwards. So thank you all. I will yield the floor then. Okay.
No more questions? There is one.
Oh, sorry. Yeah.
So to mark file system as safe,
yeah,
when they want to disallow having device specials and some of the other things, I guess this maybe out of scope for what you're talking about, but this whole idea of marking V9FS as safe. If it's .L, then it's allowing a lot of things that would, I think, make it inherently unsafe. Whereas if you're running P2000 period, nothing else, then I would think it'd be safe.
From my understanding, the unsafe part was really the handling of user-crafted data inside of the kernel. Even 9p2000.L is just passing data around between the server and the client. I don't think that.
What is time of check, time of use concerns? Is that what they're talking about? Or is it unchecked data, or do you know?
I don't know exactly what it does with the data, but there is some processing inside the kernel that is not guarded against, for example, I don't know, a buffer overflow or lying about the size of the buffer or whatever.
Yeah. Okay.
And I don't think that V9FS is actually doing much with the data, instead of just correctly giving it out to the actual processor, which is outside. So
I've had many interactions with the current maintainers for a while, so if you want to write it up, we can go to them and talk to them about it.
That would be awesome, yeah. Moody?
Might just be that it's not safe because nobody's putting the effort to say this is safe.
That's what I understood from the mailing list discussion.
I think that's probably true.
there's no fundamental reason, just nobody's done the work.
Yeah, and it's a whitelist. I mean, it's.
I mean, the maintainers are still there and they're still enthusiastic about it.
I've seen them remove other things because of that. So I was thinking.
Yeah, no, I have had interactions with them in the last year because actually they introduced a bug that was pretty bad, but they were super helpful about fixing the bug. Although the sad result is that because the bug was there for 18 months, all the 9P servers on Linux have to be willing to walk an open FID. So, oh well. But yeah, nothing you can do because it's majority of uses of 9P, let's face it, are Linux. So,
That means you can have open. That means you can have open.
You can has OpenAT, yes, because they broke they broke the kernel for a while.
Also mentioned in some discussion, but I was thinking about trying to remedy some error handling in NFS that's kind of moving from exact strings to straight prefix matches. If you use export FS directly and the kernel gives back a nicer error string than V9FS expects, V9FS freaks out and can't create files anymore. Because it has a file name in there. Like the kernel says cannot walk, because the V9FS tries to walk to a file first and tries to open it, and if it fails to open it, then it tries to create it, but it expects a very specific error from opening. So you have to, it has like a list of strings that have to just mem constant. So we want to do prefix matching and kind of shift stuff around in the kernel and hopefully make that easier to do. But I don't have any experience doing it. We have patches.
I very strongly came out against that way of handling errors for that reason. And I lost that argument.
Really?
Yeah, I was really pissed off when that went in, but yeah, oh well. Be happy to talk about that too.
We can talk about, but actually, yeah, we should talk, for people that are interested in chatting about 9P error handling, find us in a little after the talk.
Yeah, thank you very much.
Thank you.
Let's talk for today. We're now hearing about NeoVenti.
So I'm also going to apologize for the fact that I put these slides together mostly today. So typos will probably abound, and if not, I apologize for making it not look bad. So what is a computer for? Because technology cannot be extracted from its context. Technology is created for a reason. And computers exist mostly for how we use them. To actually get stuff done, to do work, to do research, to talk to people. The point of a computer is what we do with it, not to spend forever working on making the computer itself better. So with that in mind, I'm going to get into why I'm rewriting my file system. So once upon a time, I bought a computer that ran Windows 10, and it had 2 gigabytes of RAM. So needless to say, a few minutes on the internet later, I found out what Unix was and was getting rid of the entire operating system. So, but where before it barely managed to turn on in 5 to 10 minutes if it was lucky, and spent 90% of its time on swapping to eMMC, it ended up able to get complicated games at 60 frames a second without any difficulty. So computers, when you remove a lot of the layers in the garbage, are capable of quite a lot. And a couple years after that, I was complaining about Linux to somebody for the umpteenth time, and they mentioned Plan 9 and that I would probably appreciate it more. So having a spare ThinkPad lying around, as one casually does, and having discovered that the front had fallen off, I grabbed a USB, put 9 front on it, and started playing with it. And initially I was using CWFS just because that was the default option in the installer, and I had no idea what any of the options meant. So I just didn't think about it until it crashed and the ThinkPad lost power and the file system got corrupted, and suddenly I spent a little bit of effort thinking about what my file system was. The file system was completely recoverable, to be completely clear. The data loss was entirely because I didn't bother recovering it properly because I had a perfect excuse not to. But I also wanted to toss Plan 9 on a server at the same time, so I decided, hey, why not just play around with Venti, because I've heard really good things about using it in network setups. So I started messing around with it. And at first I just set it up in addition to CWFS and started tossing like media and such on it. And I'm just gonna also quickly note that the man page, really Acme? The man page has a very accurate complaint that setting up the server is way, way, way too complicated. Having never done it before, I think it took about 2.5 hours just to figure out how to format the freaking thing, which is a significant downside compared to the other file systems where you can just hit enter in the installer and have it work. So I did eventually get it working and playing with it, and for a while that went okay. I was using it for archival, for music, tossed some games on it, some PDFs just to play around with it, kept some archival root scores of like my home file system, and it mostly went well, so I decided to grab Fossil and actually try and use it as a file system. And that also mostly went well until I found a 4 gigabyte RAM module to toss in my ThinkPad, couldn't figure out what to do with my now 8 gigs of RAM, and went, hey, let me throw it at the cache. Because everyone, like in the Linux world especially, always talks about how unused memory is wasted memory. I've got 8 gigs of memory here, I might as well do something with it. And now seems like a good time to take a break from what happened there to talk about what Venti actually is, so that I can get into why things immediately went wrong. Venti is a network storage system which effectively has 2 primary operations. You give it a blob of data, it gives you an address back. You give it the address, it gives you the blob of data back. And it's content address, so these addresses have nothing to do with where on disk the data is stored. It's just a hash of the data. So if you write the same data to a dozen different machines, all completely independent, all with different sets of data, you're gonna end up with the same address. You can read it back from any of them easily. So this can be used to set up like load balancing or replication pretty trivially, or a caching system. But in general, if you write the data to multiple Ventis, you get the same address. So if you read the blob back from all of them, it should always be the same. But storage devices are basically just giant blobs of data. Since Venti is giving a hash of data and it's just picking the address based on whatever it decides, which I'm not getting into just yet, it has to also keep track of where information is. So it has a map of the addresses it gives you, which are SHA-1 hashes of data, and it basically just keeps track of the value of where on disk it's physically storing it. So if you write the same data to 8 Ventis, each of them will give you the same address, and then it'll write internally, actually I put that in a completely different spot from all the other ones, but shh, don't tell the user that. So when a write comes in from the client, it basically just finds the end of the data log, creates an entry, puts the data there, bumps the counter, puts the entry in the index, and then hands the address over to the client. And I ran this earlier just to make a demonstration, but if I run the exact same code right now, you can see the hash is literally the same because it's the same data, same place. And I'm sure if I were to take the time and effort to actually manually scan the disk, I could find what address it picked, but I don't care that much, and I don't think anyone else does either. But the basic concept is then if I had this empty data log and I gave it that write, the index just now has this one entry saying, hey, it's at address 0, and if we look at the beginning of the data log, the data's there. So when I then go and do a read for that data, it's able to know, hey, let me find that in the index, there's your data. So it just looks up the index, looks up the data log, it gives you the data back. So this system as described is functionally complete. You give it data, it stores it as a hash table on disk. It's just also pretty freaking slow because it's a hash table being stored on disk. It needs to do index lookups, it needs to then look up the actual data. And if you're doing a file system with this, that means a lot of index lookups, a lot of data lookups, a lot of back and forth. So it ends up being extremely slow. So of course it has a cache, and in fact Venti uses 3 of them for reasons I'm going to get into later. So when I decided to bump the cache from 100 megabytes to about 2 gigabytes, it immediately crashed because Venti was using signed 32-bit integers to store its memory sizes. And it decided, hey, let's try and allocate 1.9 gigabytes instead of the 2.1 you asked for. So I fixed that, found some other issues, fixed those, and the more I started actually using this system to run as a computer to work on actual projects. Let me put my music collection on here. Let me work on some code project, do some art, whatever. I kept running into these actual issues, and eventually I gave up trying to fix them and decided to rewrite the system from scratch, and I could go into a very, very, very long explanation as to why, but I have a much easier solution, and I apologize in advance for this. This is attempting to install Go 1.17 to the root file system. And now it's hanging, and if I attempt to open a new window, it just crashed the file system. And I'm sorry, but I'm going to have to reboot that computer now. This is a consistent problem. This is not the first time this happened either. About 6 or 7 months ago, I ran into the exact same issue, spent 6 hours debugging Fossil, found a fix, submitted it to a mailing list that got basically no responses, and I found out a couple weeks ago that the patch was merged into 9 Legacy and nobody told me. So there are a lot of issues with this system, and the long story short is that trying to fix them is a loser's game because the system is not failing because it's not failing because of minor issues. It's failing because while the design of Venti and Fossil at a high level is pretty well done, the design of the implementation is absolutely atrocious. And it's severely over-engineered, so trying to basically patch it over with duct tape just results in finding even more problems to deal with. So let me kill draw term if I can figure out how to do that. And reopen it. And grab a new IP address. Okay. Okay, that went well. So with all of the context it's explained, it's probably actually helpful to go into the technical details of how NeoVenti works, how it compares to Venti, and how it actually solves the design problems. So just as one quick, very simple example, this is the implementation of the hello of the protocol, where the server and the client start greeting each other. So in NeoVenti, it basically, the Venti protocol starts by negotiating the version of the protocol itself. And after that version negotiation is done, we receive the hello packet, make sure it is actually the hello packet, that it contains the correct version of the protocol that we speak, which is 2.2 for whatever reason. I have no idea why, and this is not documented anywhere, nor is there any history explaining how this has changed over time. it just sets the version of the server effectively, just because I labeled it no, and I don't remember why I did that either, and then just sends that hello packet back. For comparison, here's the same code from the original Venti prototype. And the first thing to notice is it's significantly longer. The second thing is probably that it does multiple rounds of memory allocation and deallocation of data that it already has. It uses multiple layers of abstraction, so it has the foreign call wrapper over the packets over the actual memory. That packet interface is 1,000 lines of code, which is used to defragment this memory, which is coming in as single packets of data over the network and therefore is not fragmented. And in fact, while it's documented as existing for performance reasons, I tested disabling it and it was 10% faster. So there's a lot of these. There's a lot of places where Venti makes some questionable decisions and then puts a lot of code on top of it to make up for it. Whereas what I decided to do with NeoVenti, and this is mostly relevant in that NeoVenti is largely a response to this tower of abstractions. I wouldn't normally do things like, hey, let me grab a buffer from the client and reuse the buffer in place instead of generating a new one. But I was writing this after hours of frustration dealing with the original Venti, and I went, I'm going to do the exact opposite of what they did and use absolutely no abstraction here whatsoever, just manipulate the bytes directly. And so a lot of it ends up being, a lot of the design ends up being simpler just by not overthinking it. So as one very fun example also is the, Venti has that memory abstraction layer, and that's actually where that caching problem came in. Because malloc and free, believe it or not, don't take in signed 32-bit integers. Venti had a wrapper around it, vtmalloc, which did. And simply by not using that wrapper, the bugs went away. And there's a lot of these places where it's just doing a lot of things it does not need to do. And the term, I think it was Casey Moratori who used the term pessimization as the opposite of optimization, where rather than taking the time, basically there's a couple different strategies to optimizing code and trying to make things perform well. You can just write a bunch of code and then run it through a profiler and take the time and effort to actually make it better. Or you can avoid pessimizing it by just not overthinking it, not doing things in dumb ways. Just take the time to design things and a lot of problems disappear. And one particular example of how this actually works out in practice is that NeoVenti has one cache. All it caches are raw disk blocks. So anytime it goes to read data from disk, whether that's the actual data you're asking for or the index entries it needs to get there, it reads 8 kilobyte chunks even if it only needed 2 of the bytes in it. And it will cache that entire block. Venti has an identical cache, but on top of it, it has an index cache and it has a lump cache. This is actually where some of the complexity for configuring it comes from and why it requires multiple separate parameters for how big you want the cache is. And each of those caches is implemented separately. So in the original Venti, it has 3 entire implementations of caches, each with its own free list management, with these doubly linked lists, and all of these locking structures, each of which is complete, like almost identical to the other 2, and yet completely redundant. And NeoVenti only has that one cache. And so you might think that it might be a struggle trying to compete with this much older project and to beat it in performance. But in fact, even before the cache was implemented, it was only about 10% slower. And with it, oh, right. So what I just did is I have this archival file system, which is stored in the root in Venti on my computer. It's a copy of my root file system from a couple months ago when I first started working on NeoVenti. And I now have 2 copies of this mounted in the namespace. One of them is a copy that's using Venti, the same Venti that's running the file system that's showing this presentation, i.e. the one that I crashed earlier in that demonstration. The other one is going through NeoVenti. And if I take the time to walk through them, just to see how long it takes to go through the file system, it also occurs to me I totally forgot to bump the font size the second time through. I can totally type today. One of the things that I noticed when I was working on this and what prompted some of the NeoVenti work to begin with is on my ThinkPad I have this nice handy hard drive indicator light, and when Venti is doing this right now as it's going through, 90% of the time it's doing this, the light is off, and the rest of the time it's just flickering on and off. That was the cold read. Without the cache, it took about 14 seconds. If I then do the same thing again, interestingly, that hard drive light is still flickering. Despite the fact that 100% of the data it's accessing fits in cache, it is still actually accessing the hard drive, and it takes 11 seconds to access it again, slightly faster than uncached. By comparison, for NeoVenti, the uncached read currently has the hard drive light completely solidly on. It's not even flickering off. From previous experience, this is probably going to be something like 20 seconds, so it's a little bit worse than uncached compared to Venti. Whereas once it's cached, the hard drive light never turns on and it finishes in about 4 seconds. And more interestingly, looking at the profile of it when it does, the entirety of the time it spends on CPU on the server is spent waiting for the client to ask for data. The actual I/O to disk doesn't even register, nor does the locking, nor does the caching. It is spending the entirety of its time waiting for the client to ask for more information. I ran it through a profiler once when the cache there was a bug in the cache, which I'll get to shortly, because it's actually pretty technically interesting compared to the rest of it. But for the most part, this performance is not because it's doing something smart that Venti isn't. It's because it's just not taking the time and effort to allocate memory and copy things around that it doesn't need to be doing. It's not using 6 separate locks for one piece of information when it could just not do that. And a lot of this really does just come down to if you just write less code and spend more time thinking about what the code does, suddenly a lot of these issues are gone. I literally, the first time I ran this walk of that root file system, it worked immediately. That is more than I can say about when I actually set up Venti, the original one, the first time. A lot of the reason this exists is just fix up the issues with the design, avoid overcomplicating things, and I want to be able to stop thinking about my file system so that next time I want to go and upgrade Go, I don't notice that my file system crashes when it's installing. I just want to be able to use Go. That's really all this is I spent weeks and months going over Venti trying to fix all of its bugs, and I realized it would take less effort not to even bother. And I'm just going to, I think there was a little bit more in here, but yeah, for the most part, that's it. The only thing in here that's really actually technically interesting in its own right is probably the cache. Everything else is just do things in the easiest way possible. The cache, I maybe over-engineered a little bit and spent a good couple of days reading every single paper I could find on hash table and cache implementations. To the best of my knowledge, this is the most memory efficient cache for disk usage in the world right now. And the way it does that is by cheating. Very, very, very hard. Because most of the time when you're using a hash table for some cache, you end up, what I've seen for most of these hash tables is they're designed generically. You have some key, you have some value, you don't really care that much about what the data is, because you design these tables as libraries. Any application is supposed to be able to just grab the library and use it. But it turns out if you actually are paying attention to what the data you're working with is, you can truncate a lot of that information and make things ridiculously efficient and fast. So, for instance, one of the main things, the main way this works is there's a paper called the CLHT, the cache line hash table. And the only thing that this hash table does, which again, it's not over-designed, it's just do things in an obvious way and do it right, and you get good performance out of it. All it does is design each of the buckets of the hash table to fit in one line of cache memory, which means 64 bytes. The original paper was using 8-byte keys and 8-byte values, which with the locking and the cleverness they managed to work in there, meant that at best they could get about 6 entries per cache line, usually 4. I made some changes and I'm currently at 8, and I have some design changes to get it up to 12. But the basic idea here is the keys are 4 bytes and the values are 3, because all that this is caching is data from disk. And all it's caching is blocks, and each block is 8 kilobytes. So I don't even need 64 bits of address for what I'm caching, because I'm not storing 2 to the 64 bytes of data. There's no need to address that. So if you have, say, a 64 terabyte system with 8 kilobyte blocks, and you just want to be able to index into these, it turns out that you can actually get away with 16 bits of information for, well, actually, what I'm basically doing is, Venti splits the storage into arenas. So each of them is 512 megabytes, the idea being basically that you can burn them to a CD, so you can just take your collection of 100 arenas, put it on 100 disks, and now you have a physical backup you can put somewhere. Or you can just get a flash drive, but that's just me. But so what it basically is doing is it's just going, well, okay, every block we're caching is in one of these arenas somewhere. So if we just take that arena index, and well, each arena is 512 megabytes. If each block in that arena is 8 kilobytes, that's 65,536 possible blocks per arena, which is exactly 16 bits of indexing needed. So if you stuff that into just 2 bytes of which arena is this, and then 2 bytes of which block in the arena, and the second trick is that the cache, this is a cache. This hash table only exists for caching. The value will always be a buffer. It does not need to be able to cache an arbitrary pointer into memory, because it's not caching arbitrary memory. All it's caching is if it's set to, I mean, currently this needs to be parameterized properly. This was just the prototype from a couple weeks ago. But basically, if I'm caching a couple 100,000 entries, all I really needed to do is set aside memory for, okay, 8 kilobytes of data each. And then the value isn't a pointer to random memory. It's just which buffer in that list of buffers is it. And suddenly, it ends up being able to fit 8 of them per cache line right now with the lock in there. And there's a couple of changes I have to get that up to 12, but I'm not going to get into that now. I'm just going to actually get into the only other thing that as far as I know, is actually somewhat novel in how this cache works. And that is that this does not actually support gets and puts. It doesn't support either operation. Instead, it's more of an, absurd is the wrong word, but it probably evokes the accurate implementation a little bit more. What it basically is doing is going, okay, the only time you're ever going to access this cache is when someone is either writing or reading data. When that happens, we have the key. And either we already have the data because this is a write, or we need to know whether or not we need to read the data because it's either in cache or not, we're reading data. And so what it basically does is it just says, don't give me a value, ever. Just give me the key, I'll give you a buffer. It associates the key with that buffer, and so on read, what ends up happening, and the code for that actually will illustrate this a lot more than me talking about it will. But cache lookup. This is the entire code for reading a block from disk. And other than just the assertions to make sure things are correct, all it does is it says, okay, cache, here's the arena I'm working with, here's the block in that arena I want, give me a buffer for it, and tell me whether or not I've already read data into that buffer. And if not, it reads into it. All it's really doing is associating the key with that buffer and giving the buffer back. And so the rest of it's just bog storage hash table stuff, linear probing, open addressing. It's nothing interesting or really worth getting into. But basically it just has this giant array of data and says, okay, anytime you want to insert data, we find the right bucket, which Fibonacci hashing, which basically is just multiply by the golden ratio to scatter around which bucket you're picking. And check if it's in the bucket. If so, grab the pointer, or grab the index, turn it into the pointer, and give it back. And so all this ends up being is, hey, is it in cache? If so, cool, return it. If not, let me read it into that buffer and done. And this ends up, again, this doesn't even show up on the profile anymore, just because it's nothing here takes all that much work. The entirety of the code for NeoVenti fits in less space than the headers for Venti do, which I think sums up how much less, I'm not going to say how much less thought was put into it, but more how much more thought was put into not overdoing things. But again, it ends up being, looking at the profile, I think I have one lying around here. The entirety of that time, if I can remember how to actually output this. Multiple of them, cool. that's the wrong one. But oh, and that's 5 seconds with the profiler enabled, to be clear. This is actually slowed down. That's why it was, I said 4 seconds, it ended up being 5 because it was actually grabbing a profile. But a lot of this is just do things simple, do things right, and don't overthink it. And currently, it already beats Venti in performance on the read side for almost every case, and I'm gonna have that to every very soon. Then it's just adding in the right code and moving on to NeoFossil instead. Because honestly, most of the problems with the Venti fossil system probably come from Fossil at this point still. But there's a lot of cool things that Venti enables that are very, very hard to actually do with Venti as it is today. I hinted at the fact that you can do load balancing with Venti because all of it's just hash-based data. You can put the data in multiple separate Ventis and just pick one dynamically. One of the things I originally was doing actually, I have a Venti on here, I have a Venti on a server at home. I can, when I'm online, only work on that one. The file system syncs to it. When I'm offline, basically just work on the local one and sync to it when available. So you can basically, and during the last 9 front hackathon in Brooklyn, I was able to synchronize my file system over the internet about 50 miles away in about 10 seconds. Because Venti because the data storage is append only, and all of the data just gets written to the end of the arenas, you can synchronize a Venti just by, for the first time, you just copy up all the data that's in there, and you write down where the data ended. So if it had 100 gigabytes of data, you would literally just need to write down the number 100 gigabytes. The second time you want to sync it, all you do is go, how much data is in here? Cool. From the 100 gigabyte mark to the 105 gigabyte mark, just copy that data and store it in the other Venti. And it can do this without having to look and without having to walk the file system at all. So if you have no data in there, it can detect that in under a millisecond. Literally the entire time is this network round trip. And there's a lot of these really cool features that should be really easy to do with Venti or really easy to enable. For instance, it stores data as a hash, Git stores data as a hash. Someone suggested earlier you can put Git on top of Venti, and I've looked into doing this. And the problem every time comes down to Venti just isn't maintainable. It's very hard to actually make changes to it, to actually add any kind of features you would want to it. One very obvious feature that it's missing, it stores all this data as hashes. If you have data on your root file system, assuming that this actually works with the compression, which I'm not convinced it does because the last time I tried this I had to patch it. But in principle, the file system is responsible for managing that score. So it should be able, no, that's completely wrong, that's corrupt. The 0 is at the end, that is not a valid SHA-1 hash. This disk has full disk encryption enabled, and trying to read back 32 bytes in the middle of a sector apparently doesn't go very well. But in principle, if you have the hash, you can just find the data. But the problem is if you're storing a lot of data in a Venti, you do not want to have to remember these hashes, you don't want to have to write them down somewhere. So it seems really obvious to just have Venti have a place to store this. A small key value store, something along those lines. But any change you make to Venti is going to have to deal with the fact that because of the way it was designed, there's a lot of places where it will rely on undocumented assumptions. It will actually violate its own stated APIs in some places. And there's a lot of these places where you go to fix it and you'll actually make it worse. And so one of the goals with NeoVenti isn't just, hey, let me do the same thing but better. It's let me build this solid ground to stand upon to actually start adding all of these cool features that should just work. There's these things that should be really easy to do that just aren't. And having a solid base to work with should hopefully make that a lot easier. And I will open the floor to questions now that I have talked you off for a while and crashed my file system only once, intentionally. That's a new record.
Do you actually run Fossil with NeoVenti or Fossil?
I have run VacFS with NeoVenti, which is what that walk was doing. In principle, you could run Fossil with NeoVenti as long as you don't actually try writing data to it, since NeoVenti currently does not actually have the write code in place yet, mostly because I wanted to get the caching in place first so that I could actually, basically, if I'm trying to actually test the write path and I want to write 5 gigabytes to it and it doesn't have a cache for the index data, that ends up taking a long time just because every single write has to flush to disk.
So you're using the arenas made by old Venti?
Yeah, that NeoVenti example I was using there, that's actually running off of the file system that's running NeoVenti. Yeah?
So I was just going to say that Fossil only writes when it does its snapshots. So
in principle,
you can run your file system from. You just wouldn't be able to take any snapshots after that. But you could mess about with it more.
you could use it for the historical data. The basic problem is that at 5 in the morning it's probably going to crash. By default, you can change when it'll crash.
Well, you can switch on. You can stop it.
You can turn off the snapshots, but that seems like the easy way out.
One of the things that part of the history is that it wasn't perhaps the original intention that the moment a fossil had to be attached to a venti, you could never have it go offline again.
Yeah.
It was a sort of side effect of the way it was done.
Yeah, so Jim used to tell this story about the first time he and Frasato tried to disconnect the fossil from a venti, and then they just looked at each other and went, "Oh shit, that's not how it was supposed to work."
Yeah, well, there were lots of reasons that I've always wondered about that structure that you mentioned about this. It has its own version of various things that are already there in Plan 9. Now, I wasn't sure, and I never bothered to ask anyone whether it was part of some plan to have it as trying to make some sort of product out of it, because they were looking for justification for themselves, and so they wanted to separate it from the Plan 9 source code base.
I have heard that suggested before.
I don't know whether it's true, but
I've heard that a couple of times actually.
And it would explain some of the decisions that don't really make sense otherwise.
I mean, it's interesting that there was a project, I completely forgotten about it actually, but I think it was a GSOC thing to do a venti implementation for Burner.
I think someone did that, yeah.
Yes, and I've just looked at it now, and it's, I mean, probably allocates more than you want, but I mean, that on its own is 757 lines of limbo, which is a lot smaller than the venti, and it
yeah.
wants to be able to do writes. I don't know whether it tries to cache it, more closely at it. It's just
24,000 lines, and that's not even all of it. There's more that's missing from that.
I think everybody is aware of this problem, but that's one question. Actually, kind of two questions though. So would your neo fossil be able to operate by a connect, disconnect, connect kind of model?
I've thought about that. One of the things I was working on, one of the things I was doing initially, which is why I started looking at the venti source to begin with and throwing memory at it on here, was I wanted to have a venti on the laptop and a venti on the server.
Yeah.
The venti on the server would be the primary one, and there would be a fossil on both that would stay in sync.
Yeah.
And the basic idea was any data that's important, like by default, you would want to keep some of the data on the local venti too. But you basically, I wanted to be able to differentiate between different file systems. So for instance, you'd have your root file system. You need the entire thing on every machine, basically, if you want to be able to disconnect. Because if you don't have the software on it, you're out of luck.
Yeah.
The other option for that, though, which I've been looking at, and actually I mentioned, I ran into deadlocks, okay, like with Go, it's very trivial to deadlock fossil.
Mm-hmm.
A few months ago, I ran into one. I have the notes here somewhere, I'm sure. But the cause of the crash of the deadlock there was a case. It was very simple. There was a case, an error path where it wasn't unlocking. That was it. It was really, really simple once you knew what to look for. But the problem was the code was all intermingled, and it was a while to figure out which locks were even being held at the time. But one of the thoughts that the way I was able to even debug that in the first place, I don't know if you're familiar with the ants work that Mycroft did off of 9front and off of Labs 9 a while back. But one of the basic concepts there is that your terminals are rootless. They do not have a root file system. They boot into a RAM disk. That RAM disk is basically stored in 9FAT alongside the kernel. It's basically like an initial RAM disk on Linux, except instead of just being used to contain the tools to load your root file system, it is your root. And so it'll have all these nice things in it like Rio and ACID. So you can run Rio from memory, and in a window, you run your root file system. If the file system crashes, that window is gone, but you have your main window manager still, and you can open up ACID in it and attached to that dead root file system. And so that's what I was able to do, is I was able to actually get a backtrace of every thread that was hanging at the time when Fossil deadlocked. And I honestly don't think I would have been able to debug it without that. But one of the thoughts I've had regarding the NeoFossil solution is, instead of trying to actually synchronize the root file system between all the machines, stop trying to use a root file system, so that when you're offline, if some data is missing, some programs are missing, that's fine, because anything that you actually need to be local is going to be in RAM.
That makes a ton of sense.
And it simplifies a lot of the problem, because you don't have to worry about, how do I make sure that I have enough space on the local venti. It means that, like, you can toss this on a 16 gigabyte micro SD card for a Raspberry Pi and not have to worry about running out of space for it.
So that's really nice. Right toward the end, we were doing that on Harvey too, and it was great. Just screw this root file system thing, it's long memory. But the next question on the Camly store, which has a new name now, which is a hash file system done back in the day, they decided from the beginning to prefix the SHA with the SHA type. The idea
so that you can change the hash.
So I don't have to tell my grandchildren that I used the wrong hash.
Yeah, that's one of the things NeoVenti, basically, the work I have is effectively split into two phases. Phase 1 is replace Venti. Phase 2 is fix up the actual underlying system. Yeah. Because, and this is what I was getting at earlier, there's a lot of, Venti gets a lot of things right, but there are some things, it uses SHA-1 for the hash. I'm looking at, for I haven't done enough research into this to have a definitive answer, but I'm currently leaning towards Blake 3 as a replacement, since it's supposed to be a lot more, it's supposed to be more secure at this point, like for hash collision resistance, and also it's a lot faster than any of the competitors as far as I know, and it's simple in C, so it can just be included. But in general, one of the things I've been looking at, and this is after the thing is done, is not just replace the hash once, but keep track of what the type of the hash is, so that it can actually be swapped out. The problem with that is you end up in a case where, if I have right now on here, what is it, 13032? If I have on here 100 gigabytes of active storage right now, and I switch the hash to something else, I have to be able to use the old hash to read the data back.
Yeah.
So not only do you end up in the problem where you basically have to change the protocol so that you can specify the hash with the which the hash is.
It's a change.
Just have a byte in the score to specify the hash.
I think I would need to double check, but I'm pretty sure the protocol actually hard codes the size of the score right now. So I'm pretty sure that would still be a breaking change to the protocol.
Yeah. But
because of how it's designed.
You'd be the first person to use a new version number.
I already did bump the version there, because there are some things where I am technically breaking compatibility, just because there's things that Venti technically supports that it doesn't actually care about, and I just went, I'm not going to bother even pretending to support them right now. Yeah. Like the first string, if I shouldn't do this, but in principle it's probably fine. I think I'd have to actually post to it for this to do anything, though. In principle, if you make, what is it, dial? Aux dial. In principle, if you dial a Venti server, it gives you a version string. Yeah. That whole string, nothing actually cares about it. The only thing that any of the implementations do, NeoVenti, Venti, and as far as I know, the Go one also, I didn't spend enough time looking at that to say for sure though. All it does is say, okay, now I'm going to read one byte until I find a new line and assume that all of this is garbage. All it does is make it harder to parse the hello and to figure out where to actually start the connection. If they literally just put this version string in the hello message, it would be easier to parse. But I didn't design this. I'm just dealing with the aftermath. But yeah.
I'm curious. You said that your Venti is slower doing the cold read than the old Venti.
Yes.
Have you looked into why?
I have not profiled it to figure out why, but there are some very compelling reasons just off the top of my head, which is old Venti will read the entire arena after you read like 3 blocks from it. So it's going to have most of the data in memory before the client requests come in, which again, given the profile shows most of our time is already spent waiting on the client. That's after the cache is warmed up. It's most of the, The other thing there is Venti has that index cache, which may, and the basically what that means is that when it loads in a bucket, it's gonna load multiple entries and unpack them all at once, so that the next lookup. Some of the things it's doing make it slightly faster to find the data that you're looking up to begin with, is what a lot of it comes down to. I also don't remember if I ended up hacking the index into the cache at all yet. So this might technically not have an index cache, which given that this workload in particular, that archival file system, because it's a fossil score, that means that it has the dump from like 50 consecutive days. And most of the files are the same. Which means that because it has the index cache and it's already got those unloaded during that cold run, it ends up able to skip. I say it ends up able to skip the index, but the truth is that the activity light goes on when it's doing the warm read, so I'm not going to pretend to understand what Venti thinks it's doing anymore. I gave up on pretending that a while ago. There's a lot of things that the documentation will say one thing and it's pretty obvious that that's what it's supposed to be doing, and then it ends up doing something that's very different. So just because of emergent behavior, where like it'll end up thinking it put something in cache and then we're dumping it out 10 seconds later, even though it has plenty of available cache room. So there's a lot of assertions in the man page about how you need to set the cache to XYZ size in order to make sure that you can sustain a certain throughput, and all of those numbers are completely and utterly lies. None of them has any connection to reality because what the code is doing is not what they claim it's doing.
Is some of it just the factor that in 2002, 2 gigabytes was big?
Some of it is. Some of it is definitely also that a lot of this didn't matter when your workload sizes were single-digit gigabytes, double-digit gigabytes. Because if 10% of your workload fits in your 1 gigabyte of cache memory, then it's very different. Yeah. But at the same time, this particular case makes me think it's not just that, simply because this is not a huge archive. This file system that I was running through is, I mean, this is including all the fact that there's multiple copies of everything in it, and it's still 2 gigabytes because this is the home folder. It's largely like text files and code. With the archives, it's 2.2 gigabytes. So and just walking the tree with Venti with a warmed up cache takes 12 seconds if you're lucky. It's some of it comes down to the design not being optimal for today's systems, but some of it, like, okay, the signed 32-bit integers for memory sizing thing is easy to laugh at now and go, why would you ever think signed integers? But at the same time, if your memory is less than 1 gigabyte, it doesn't really matter. Because yeah, it's wrong, but it's just an int. It's not like you specified signed, you just didn't think about it.
Well, also apparently there's a bug in indexing things with unsigned values.
That's true, but given that I fixed the bug in Venti before that was fixed.
No, I mean, I was looking back at really old source, and there's this comment about there, save more for the big boys. Well, the big boy was the 36 socket SGI machine that had 128 meg of memory, which was like,
yeah,
this
some of it.
A massively large amount of memory. So
on the other hand,
well, not really anymore, but yeah.
On the other hand, you also have things like it has a disk scheduling routine, where basically every time it goes to make a disk access, so if it's for the index, for the arena, whether it's read or write, it keeps track of it. Yeah. So it looks at the last time, and then if you, anytime you want to make a request, you call this function, and it basically says, we're going to check how active the disk is for reads, how active it is for writes, and based on whether or not the workload you're trying to do is prefetching versus actually grabbing data that the client is asking for, it'll make you go to sleep and wait.
Wow.
And I had an experiment. I stripped this code out and tested it in various workloads, and I literally couldn't tell the difference. Yeah. And this is one of the things where I think it might actually just be that, hey, it made a lot more sense on older machines where it was more affected.
I had an interesting conversation with the storage person at Google about actually 15 years ago now, and I said, with the disks you guys get today, how many games does it make sense to play in terms of optimizing performance? And he said, basically none. They're already so optimized internally, you're unlikely to do better.
To comment on it. First, even spinning Rust has native command queuing, so it'll reorder your IOs.
Yep.
But the other question, Have you actually tried this on Spinning Rust, or has it all been SSTs?
I did try it on Spinning Rust a while back. Unfortunately, well, actually, I was about to say 1,000 miles. My server is currently a couple hundred miles away and has been decommissioned for a while for noise reasons. So I haven't tested it on that.
Say noise reasons?
Noise reasons. I kept it in the bedroom and it was loud. And I decided that my sleep was more important than having a 24/7 Spinning Rust thing on. Yeah, but but yeah, some of this is stuff that I'm not certain I can believe. I would need to test this to decide whether or not it made sense when it was implemented. But a lot of it is stuff where a lot of it is stuff where it really does look like this was a prototype. And I mean, that was explicit in the paper, for instance. This was an experiment, and the fact that they ended up actually using, I mean, okay, one of the things that makes me lean towards the hypothesis that they were looking to commercialize it at one point is the fact that it has code for generating stat graphs for statistics that under no circumstances do you actually need to know, because they tell you nothing useful about what Venti is actually doing. But it's the kind of thing I could imagine that they would think would be like, hey, we have pretty pictures of what's going on.
Also, they have JavaScript.
In Venti?
I'm pretty sure it serves some HTML with JavaScript.
It serves HTML, but I have not seen any JavaScript in there.
Okay, I could be wrong about that.
I'm scared now, but I don't think so. It has these endpoints for doing things, but I don't think it does.
But nobody on Cloud 9 is using that.
Right.
It generates, I mean, the HTTP server is basically really only useful for getting the information you need to do to copy from one Venti to another. And that's really the only reason that this server should even exist right now is because the protocol is missing some requests.
Yeah. Oh, no, I'm wrong. I don't see the JavaScript.
An alternative I've often thought of doing, what I haven't had the time to, was to rip that out and put an IP server in so you get information from IP.
That is in the paper as one of the things that I want to do.
I didn't read these things to avoid spoilers.
No, that paper, honestly, I need to rewrite it. It was very rushed. But the talk was better than the paper, and that says something.
Too important and using scripts and so on.
Yeah, I've definitely thought.
Whereas if it's in the protocol, you'd have to have new protocol messages, well, the usual problem, new protocol messages from new metadata, and I think protocol being focused on just the basic caching.
I kind of want to just kill the protocol entirely and just use 9p, because if you can just mount the Venti and go, hey, oh, right, the aux style is
That
on.
would be very nice.
You could, in principle, just be able to do, hey, cat some hash here.
Yeah.
Or you could build on top of that and do something like what GitFS does and just go, hey, we have this hash tree. Let's just, you access the tree, you access it as the file system directly. There's no particular reason it couldn't just synthesize this on demand. Toss fossil in there, like fossil. Just toss in some hierarchical system in there while you're at it, and a lot of this could be a lot simpler. If you had, basically, if you toss in just some light key values read-write buffer into Venti itself, you could use that for storing root scores so you don't have to memorize them, so you don't have to store them in your file system, which is itself stored in Venti.
I think I'd probably do that as a separate service so that it's composed and focused.
Yeah, there's...
I agree, you don't want to store them locally.
Yeah.
For most us, there's never lost the score.
Exactly. I know Mycroft for Ants had a system where it would automatically back up root scores into 9FAT, so that if the system crashed, it could automatically grab the list from 9FAT, grab the latest one, and reinitialize your file system for you. I don't remember if the script actually did that, but it definitely had the information too, because I remember looking at that and going, huh, that's neat. I should play with that more, and then never doing so.
Maybe it's for Mac, but from the server you can list them chronologically, and then you can take the last one and hope it was the whole one.
You're saying if you were to store these in the server?
You can get them back to the server. But
You can scan Venti for all root scores. The problem is because basically the way that it does this is it goes, okay, root score. We know what a root. We don't have a list of root scores. What we have is we have the data log and we have the index. The index is useless. We're going to ignore it. We look at the data log and we just go, okay, I have 94 gigabytes of data. That's rough. If we look at it here, that's roughly 14 million blocks. So what it does is it goes, okay, let's read every single one of those 14 million blocks and check if its type is root. And if it is, print its hash.
Yeah, I've done that. It takes a while.
Yeah, it's not only just that it takes a while. A lot of the Venti tooling, again, this comes down to a lot of this. The ideas are good, but the tooling, setting up a Venti server is too complicated.
I believe that everyone was rushing off to Google at the time.
Yeah.
A lot of it. I mean, okay, one example of this.
Everybody involved was rushing off to Google. I mean, yeah.
One example of this is the tool that you use to write data, raw data to Venti, the write arena. Basically, you grab the arena from one Venti, pipe it over the network, and then you pass it to this tool, and it will just take that arena and put the whole thing in. So if you do this to every arena on the source Venti, copy and just insert the entire thing in the destination, it will synchronize the entire Venti start to finish. And you keep track of where you left off. The next time you do it, you start at the end of the arena, and it can just not have to look at any of the old data. What I described is how it works in 9front as of the hackathon when I fixed it. Before that, it would actually do, even when it had, basically it would scan the data it already knew that it didn't need to. And the way it did it was, suffice to say that I effectively inlined a solid third of Venti's arena reading code and then cut it in half, because a lot of what it was doing was completely and utterly unnecessary even in the normal case, and I just didn't bother fixing it there. But a lot of it really is just, basically what it's able to do is just, now, if I run this, I mean, I don't have a remote machine online right now to actually do it with, but now it can, you can actually do it on the arenas you've already copied, and it'll detect it automatically quickly. And it can, a lot of this was really just, the main thing is it just reads the entire arena into memory at the start and then just sends it over the network. Whereas before it was actually going through the Venti logic and caching. And it was spending more time evicting its own entries from cache than it was actually sending data over the network. So again, there's a lot of this which is just, one of the things I also want to do with Venti, with NeoVenti, is actually write a replacement for libventi also, so that a lot of this tooling can be cleaned up and improved and expanded on, because it would be really cool if we could actually just put Git on Venti, or if we could actually just have a load balancer, or a cacher, or torrenting, for instance.
Load balancing with the hashes, you do something like chord, for example, to circular hash to serve around a set of servers redundantly.
Yeah, there's a lot of these things that the tooling either doesn't exist or is so haphazard that it's harder to figure out how to use it than to rewrite it from scratch. This tool is technically documented, but the best documentation of it is the RC script that was lying around somewhere on, like, without, yeah. A lot of it is just really good ideas that could be done a lot better, and basically, it's very easy for me to come in 20 years after this was done and go, I can see all of the things you did wrong and I'm going to fix them. But I can only do that because they did this 20 years ago, because people have worked on it since then, and it's very obvious in hindsight what the flaws are. The only reason that my solution wins right now is because I had this to use as a reference of what not to do. Basically, they took, normally, for my own projects, for instance, there's a compiler project I've been working on off and on for years. I have thrown out the entire code base 6 times now and started over. And with Venti, I got to cheat because they already did it for me. So it's not so much, I don't want the message here to be, oh, Venti is terrible, Venti sucks, Venti is really poorly implemented. Venti is a really well done system that was just done with no prior art to work off of. I'm not coming in and magically fixing things. I'm just coming in and going, okay, now that you gave me this framework that I can build on, I can see what you did right, I can see what you did wrong, and I can make it more cohesive.
Well, there's similar things with Fossil, where it potentially spends a lot of its complexity fussing over buffering stuff. And as you get into SSDs, let alone NVMEs, I don't know. Buffering, because it's trying to organize dependencies amongst the things, so that it puts things out in a safe order.
That's definitely true, but there's also a lot of what it does. When I did test it on spinning Rust, it wasn't faster there either. For all I know, that's just because modern spinning Rust has the SSD cache built in, like the DRAM. I think like 32 megs might not sound like a lot, but when you're talking about 8 kilobyte blocks, it might mean the difference between needing a couple hundred lines of. Basically, we don't have like. Yes, like Ori pointed out, the spinning Rust disks do have queue management on the chip in the disk itself.
Well, but that can also work against clever logic that tries to arrange dependency.
Exactly, but
well, we'll just shuffle things ourselves.
But it is worth noting that even if those same systems existed when this was first designed, which I don't think they did, they definitely weren't the same or nearly as complex as they are now, where now it's basically just, an ARM chip that they toss in there, give it on some of the terabyte, like if you have a 4 terabyte spinning Rust disk, I think they give it something like half a gigabyte of DRAM. So it has a lot of resources. Like the microcontroller in a spinning Rust drive now is almost on par with the computers that they were working with originally. So yes, a lot of this complexity is silly and can be thrown away even on systems that feel old now. But that doesn't mean that it made no sense when it was written. It just means that history has changed. We've moved on and it doesn't make sense anymore. On the other hand, a lot of this never made sense. The layers of abstraction, to the best of my knowledge, have not been optimal on any computer that has ever existed. And I'm fairly sure there are multiple programmer Bibles that will effectively say this is exactly what not to do for optimal code. Just because, it's less of a problem for us, or possibly more of one actually. We have less fancy optimizations in the compiler that this kind of abstraction can interfere with. But on the other hand, we also have things like completely no inlining. So suddenly tossing 20 unnecessary function calls in a hot path can actually be a problem if you're shuffling a lot of memory around when you don't need to be. But it says something that Venti is actually accessing the disk when the cache is warm, even though it's full. That's pretty symbolic of the kinds of issues that I was dealing with trying to fix the system. Or the packet code is a great example. Venti has a packet layer. The libventi, which is the core of the original Venti server, basically. Original might not be fully accurate. So this is about 1,000 lines of code for managing fragmented buffers. The main problem I have with this is that those fragmented buffers don't actually exist. And to the best of my knowledge, every single one of these has a frag of 1, except for when it is synthetically splitting buffers in 2 to insert stuff in the middle, in which case just stop doing that. But
well, again, I wonder whether that was part of some. Well, it will eventually deal with IP level fragments directly itself.
Or this code satisfies our claim in the patent.
So the Western Digital
true.
Yes. Western Digital 16 terabyte doesn't have gigabyte cache.
So if there are any other questions, I think we'll probably take it to the bar or down here. We'll figure it out.
Yeah.
That's terrific.
Yeah, okay.
That sort of concludes today for now. I'm going to end the live stream now. I'm happy to say we had about 20 people watching on average, including from Australia and Japan, so we are all around the world. And with that, see you tomorrow.
So, as I said, we do have a dinner bar on the schedule. Unfortunately, because I'm lazy,
I hope you don't mind if I